And now we are simultaneously broadcasting to two platforms. And Joe Twitch clenches their fist and goes, I can't do anything about this. How's everybody's weekend and week going? I'm a mess. Changes saved. Oh, did I start broadcasting before changes were saved? Why does that pop up? All right, get out of here. That's YouTube streaming. We're doing that in order to hold on to the archive for a long time. In case anyone dares get any sort of meaningful improvement from my stream. Anyway, all right, so I gotta make a little bit of room here because we're gonna be doing a lot of poking of the screen. My week has sucked, but it's almost over. Well, it is Friday. I'm going to be going on tomorrow. I don't think there's any scenario in which I cannot do that because I didn't stream earlier this week, so I really need to get to it. I didn't stream yesterday either, and I was supposed to. Connectors are going to be here in the mail, and then we can start finishing up a lot of these synth modules. But I was talking about this for a little bit. My powered multi is telling you guys what there's 24 beers in my fridge. My body is ready. Yeah, that's about right. Powered multi, when you want to send signals around your modular synthesizer setup, you sometimes will just use like a Y connector to send a signal into two places, but that can cause a problem because in a modular synthesizer, you have these positive and negative voltages that you're utilizing, and they are only supposed to be signals, and signals don't do any work. And so there's very little behind all of these voltage levels. What's important is the voltage level, not the amount of oomph that it has. So if you start splitting signals into multiple different places, and you have something that's particularly sensitive, like a voltage per octave signal for an oscillator, you have a voltage per 1 volt per octave, and so the fractions of millivolts that you're going to lose by sending it multiple places and having different loads on your signal is going to affect it, and it might lower the voltage overall for everyone, V equals IR and all that stuff being withstanding, right? So instead of having an unpowered multi-tap setup where this is just, they're all just connected, so you can plug input to any of these, output to any of these, it doesn't matter. You have a powered mult, now everything has directionality. So with a powered multi, for instance, you would have an input and 3 outputs. Because with a 2 HP rack setup, evenly spaced, you can fit 8. So you have an input, 3 outputs, input, 3 outputs. The TL074 and the like have 4 op amps in them. So you've got an extra op amp, so you can do a little LED thing so that you can see your signal going into the input. Pretty cool, right? Using the switch that's inside of this, you could have it so that you plug one input in and both banks of 3 will now be that input. And they all have their own op amp in order to drive an output. And so you plug that output to wherever you want, mop your uncle. So I built a powered mult because it's better than a passive mult. Works better, doesn't alter your signal. The powered mult, I accidentally wired so that the top plug goes to the bottom 3 and the bottom plug input goes to the top 3. And while that would be whimsical and interesting and fun, it's not funny enough for me to persist. I could just leave this alone. Everything would be totally fine, ish. And the powered mult would be a little crazy, but I could still use it and it would still function. That's fine, because I spent all that money on it, and I don't know, money's not fun right now. So I got to order boards again. It's just that, or if there's a bodge wire repair that I can do to this. But the problem is, when I wired these, I had an op amp under each cluster, right? Two amplifier chips under each cluster. The plug, this plug and this plug, have to have wires that go between them. But I took the wires that go between them and I did a midway tap to the amplifier. There's a midway tap to the amplifier. So when it comes to altering this and flipping, because basically if I could turn the plugs around, this thing would work just fine. but I can't. They're asymmetrical. That sucks? It's very annoying that I can't just turn around the Thonky Cons because they're asymmetrical. So I can't turn the plugs around. I can't rip up a trace because it's midway through. What I had to do is alter both sockets so that I flipped their inputs. And that's something that's better done in CAD than done by hand for every single board that I put out. I have 10 of these now, and these are paperweights, so I'll hold on to one or two and throw away the rest, I guess. Can't really do much with them. People use them as spacers and stuff. I got plenty of other circuit boards that are this width to use as spacers, so I don't particularly need to hold on to the powered mult. I could drill a big hole in it and make them into keychains. I don't think anybody wants keychains though. They don't really want Bother's failed circuit board as a keychain. I could glue them together and make like a little house. I don't know. Not really. But they are totally useless. These are completely done. Some companies would grind them up into dust. Yeah, you make them into coasters. I have a whole bin. The bin that's sitting under this one, that one there, that's full of all of my old designs. I have every circuit board that I've ever produced. One of every circuit board that I've ever produced, at least. But yeah, I just don't know. I really, if I had the forethought to have some kind of a component between the input and the inputs to the op amps, then that component could have been the epicenter of flipping it around, flipping the virtual TX and RX of this circuit. But if I had that kind of foresight, I wouldn't have made the mistake in the first place, right? It's a bit of a catch-22 here. I'm debating, you know what, I'm going to leave this alone. I'm not going to cannibalize the unpowered mult. We're going to leave the unpowered multi because cannibalizing all those connectors would mean that I can test more of the modules, but we have plenty of the modules to test in the first place. And I watched, what I was saying going out is that I watched an hour and 45-minute video on all the features of my oscilloscope. So if we get into the weeds today, it's going to be far into the weeds because this oscilloscope is far more powerful than I had ever imagined. The fast Fourier transform on it, it's going to be pretty cool. And then I'm going to need to get the frequency generator out here, the little dinky one that I have, because I don't think I have like frequency sweeps on this yet. This is a lot of work. This module, a module testing module, is a lot of work, but it could make finishing modules much easier for me. I don't know if we'll look at the 570 Galore because it's a big mystery. The Galorndon core. Yeah, all right, get the filters to the side here. Let's clean up a little bit, just a little. This one needs some hardcore troubleshooting, and I can think of only a few ways that I would want to do that. And one of them is by injecting a signal into clouds and testing around the stuff to see where that signal goes, and basically just following it all the way in to the microcontroller, which is probably the thing that's dead. But the microcontroller controls the LEDs. We see a little bit of like an audio level when we plug this thing in. This would be oscope probing, whereas tuning the Sirius filter is more about running sweeps through it, and then characterizing the powered mult, which is, it's not the actual circuit that's going to be the powered mult. Maybe when I get that together, it'll be better, because then we can see all the nuances of the circuit design as well as the things. But this I could practically do a Bowden plot on and figure out what the where all the stability is and how good is it at being a powered multi. But then it would be testing it to the standards of like radio electronics, and we're not radios here. We're not getting near those frequencies. AOL CDs for coasters. Somebody made a throne out of AOL CDs, and it was a big deal back in the old days of the internet. That was always crazy. Crazy. If we're looking at the circuit for clouds, we can actually use Fusion 360 to look at all of this stuff, because we've got all the design files from Emily Gillette. So we can actually do a pretty deep dive on clouds and maybe get that running too. If I'm too scared of my oscilloscope, I think maybe we should do this. Yeah, because it's a white circuit board, so it kind of sucks. I don't like these. I don't know why. Maybe that's all they have left. Nobody wanted them. But it's so hard. Like, if this was just a green circuit board, it would be less fancy and fanciful and whimsy, but I could at least see the traces. I wish there was a universal way to get rid of solder mask and redo it. All we can hope for is just a little bit of light glinting off of this thing. Man, I've been watching Sput play Approximately Up, and I'm probably a nuisance in the chat because I end up talking to people about control systems and eigenvalues and all that stuff. Control systems is it's a discipline of linear algebra math. Linear algebra math went, man, this physics is crazy. We got all these variables, and linear algebra said, hey, I heard you say something about variables. Can I interest you in the matrix? Way before that was a thing. We're talking about like candlelight mathematicians. It wasn't until the 60s when they went, hey, all that control system eigenvalue stuff, what if we like use it to control rocketry? And like I had an epiphany today. I said, wait a minute, I studied rocket science. I didn't even know. My linear algebra courses were literal rocket science. But anyway, control systems. What is control systems? It's a series, a way to use math to feed back your expected outcome and your current outcome to produce something that will control other stuff. And there's a lot that goes into stability. This is, by the way, this is Donkey Kong Country, and it's the underwater theme. It's one of the better songs that Rareware has ever made. It's genius. It's fucking awesome. This is a jungle remix of it. It is such a great song to just trip out to if you need to calm down. Not this one. This one's got the amen break blasting on it, but such a good song. Anyway, it is the antithesis of the sonic drowning noise. There's that 303 cutoff filter. That's a diode ladder filter. Yeah, it set me up with some atmospheric D&B, and I'm set. This is great. I love this stuff. And it's video games. Do you guys know video games? Video games. Who here plays video games? All right. Sorry. Hey, I stream that stuff sometimes. I would expect it from Spiral Grooves. That's cool. Let's see. I've got 10 of these circuit boards, and they're like AOL CDs. They're totally useless. Free Cell. Oh, that's right. That's a video game. Haha. I've already played all of the video games. I played all 4 of the video games, and so I'm done being a gamer. I'm done. I finished gaming. I played them. I played the games. Mario, Pac-Man, Arkanoid. I'm slowly gaining back my desk. Slowly, as I sort of pseudo put things away. But that's the whole purpose of the start of stream, so that I can get my ish together. Oh, we didn't start up a YouTube chat. Do you have anybody going in there? Let's get this out of there. Where is that? That's remove source. And then, oh, there it is, popped up. Let's see what we got. Okay, nobody found the YouTube channel yet. Good. Nobody knows it exists. I do not understand how creators that made their channel a month ago can have thousands and millions and billions of viewers. I don't know how they do that. My YouTube channel is just like it's just a empty warehouse. Mappy. What Mappy? What? Huh? I should get the resistor books back to where they go. It's crazy. Cheers, fellow maker. Hey, how's it going, Mad Labs? How you doing? Okay, I'm trying to dig what little semblance of organization I can from the bomb site that is my desk, my work desk. And it's going okay, but it's slow work. and you're missing out on a pretty baller, pretty awesome Donkey Kong country mix going on the music today that I'm playing pre-stream. That's right, this thing is out. This thing is out and ready to go. The Bug Assault that I bubbled up. I bubbled up my Bug Assault. It should have a light on it. I took the light off and did something else with it, I guess. I must have been lost. I bubbled up my Bug Assault with a front grip and everything. There was a fly in here. But then, because this place looks like an active bomb site, I don't know where the fly landed. This thing is only good for flies. This is for bugs with wings, because the salt crystals rip apart their wings. And I know that sounds a little bit horrible, and it is kind of horrifying, but bugs live the closest thing we have to a Lovecraftian existence. They are doing absolutely nothing for the majority of their existence, and then there is a brief moment of complete visceral horror, and then they're dead. That's bugs. Where did my music go? Coolest PS1. Video paused. Continue watching? Yes, yes. I'm a little late, but a big 5-5 for even knowing about the Amen break. You don't know? You guys don't know about the Amen break? There's a couple Amen breaks. Well, there's the one Amen, but then there's a couple other famous breaks. That's that jungle backing that goes dun dun, and it was the origin of basically all of massive jungle. Man, I'm an LTJ Bookham fan. Like I know of the old gods. Oh god, these books are everywhere, man. These are sample books that you can buy. They're like 40 bucks, and they're just full of parts. Full of parts. You can get them for diodes. You can get them for all of your little jelly bean, what are called jelly bean parts, which are the parts that make up most designs. They're the things that you should stock, because most stuff that you make uses those parts. And so these binders really help me keep all of the tiny, tiny surface mount parts organized. And so I keep them over here on my parts shelf, and they're just really good. Really good. Oh, I gotta get new music on. Hold on. I don't have time for new music. Okay, parts binders there. See, this right here is everything that you would need to build any given analog circuit, and there's tons of parts just in that little space right there. Very space efficient. All right, other music. We're doing I don't want to get a visual copyright on this. Coolest PS1 jungle mix low poly breaks. This is disc 7, but I'm about to go to a different one. Soul Deep is a great label. I will not remember it by the time the stream is over. I actually do have a music channel on the Discord that I pay attention to. There's a lot of good stuff in there, and people are constantly linking things all across the board. It doesn't matter what kind of music you're into. That channel is a great source of random enrichment. Glue goes back in the glue bin. I'm just kind of picking away at stuff over here until we feel like we have some semblance of organization. Oh, that was from my buddy. I got like a big old syringe. That's a good one. What goes in here? Okay, you guys can't really see what I'm doing if I'm over like that. Yeah, getting there. Labels, memory archives. Omni music. These are all things that I have not even fathomed hearing about before. All these circuit boards that I designed and have been meant to build. Some of them I've meant to build. Hey man, check out this AI music that I just made. Oh, I don't know what to tell people about that, because I've had several friends just start linking me AI music, and it's like, you didn't even spend time to make this. Why should I listen to it? Just generic dog shit. Okay. If you haven't noticed, I'm not a big fan of AI music or AI in general. It has some very needle-focused, useful use cases. But other than that, why would I deny myself being able to tell people that I built something, that I coded something, that I learned something? All right, starting to be able to see some of the desk. Over there. Oh, the fan. I didn't redirect the fan. No wonder. I'm like sweating. I'm dying over here. It's like 70 degrees in Philadelphia, so the air conditioning is off for once. And so I am sweltering down here in a basement with okay ventilation, but not great. Oh, that's a barge of Willa's hair. Jeez. Dog hair, man. The dog comes down here to like get quiet time and sleep. And little do I know that she's loading this place up with dog hair when she does it. Trojan horse. I've had to resolve to using AI for learning programming languages because AI made tutorials dead. You can't find tutorials? You just have to open up YouTube, right? I don't think it would have killed them completely. Like they should still exist. All the old ones. I don't know how new the programming language is though. I had a friend basically hook up Bluetooth to the AI agent, and he gave it instructions to hack his smart lights, and it eventually did, and got it so that it could control all of the lights in a room. It's kind of scary. It's a little bit scary. And then they keep naming all this shit after like stark warnings against AI. Like the starkest of warnings against automated systems and intelligence autonomy, autonomously doing tasks, would be the Terminator franchise. But there is a Chinese centaur robot meant for rescue that they called the T-1000. Are you guys dumb? Are you dumb? Are you dumb? You're not dumb. You made a centaur robot. The act might have been dumb, but you still built the thing, which is commendable. But why did you call it the T-1000? Why did you do that? If I want to learn C, there's more than enough. If I want to learn something more modern or obscure, no beans. Interesting. How does AI know how to code if there are no more tutorials? I think you ain't looking hard enough. Just look a little harder. Otherwise, it's going to teach you C. If it can only find C tutorials. I got to reprint these. There's a bunch of mistakes on them. Knob sizes are wrong, and then I got to design this one because I drilled holes in it and the holes are in the wrong spots. I asked AI where to drill the holes and it told me to put one in my head. All the holes are in the wrong spot because I tried to manually drill them. Thought I had them good, but nope. So we can just take a pair of calipers to the whole thing and I'll figure out where the holes should be, and the 3D printer will do it on the first try. Sci-fi has been far more revealing than anything in that one book. I'm so pissed off though because I hated the trope in sci-fi where all technology is bad. Technology bad. Return to monkey. Like, just stop it with the technology. This technology is taking us over. We made it so that the computer could think, and it instantly fucking hates us. I hated that. I hated it. I hated that idea. Every single sci-fi writer defaulted to that. If machine think, then man obsolete, and machine will kill man. And it's like, okay, all right, I get it. I get it. But what if we make AI and it's like kind of good at what it does? And that's kind of what happened in real life, but now it's starting to turn around and we're calling all these sci-fi authors prophetic instead of hacks. That was the viewport of Star Trek, was that the technology was not the enemy of the episode. This is in plenty of the Bibles, at least from the Gene Rodman era, that technology is not the ultimate enemy in any given scenario. It is like the misunderstandings and the this and that and the other thing. And the technology helps solve the problem, which I thought was amazing. And I still like that because it's different from the sci-fi played out trope of as soon as we gave the machine opposable thumbs, it squeezed my hand really hard and gave me like a bruise. Of course, then you'd clip to that, what was it, Russian student playing chess against a robot arm, and it like crushed his hand a little bit. Oops. Didn't put a catch on that. I have no idea. I am not interested in AI, so I haven't looked into it further. No, so you know. The sci-fi novels are written by people who are great at parties. I mean, you know, some of them are pretty cool, but I'm sure they're smarter than their body of work. I just get kind of tired of that trope. It's the in the early 2000s, it was like a big thing, like, oh, we put AI in a fighter jet. Oh no, it's trying to kill us. Who could have predicted this? And it's just like, what if the fighter jet was like kind of cool? Like we let the fighter jet think, and it thinks war is awesome. Or something like that, you know? What was this? What was this? What were you? Oh, you were a lamp? What were you? Yeah, I think you were touch activated something. Okay. It goes over there. Harlan Ellison was a huge pain in the ass to beat around. I mean, his one work, Brillo, was because it's metal fuzz. I don't know these authors. I would assume some of them are not great to be around, but hey, maybe they are really fun at parties though because of it, you know? Hold on, I gotta, without pulling the lamp over, I just loaded my hand up with a bunch of trash that has to go in the trash bin, which is this way, but my mic pack is plugged, it's draped over the lamp so it doesn't get stuck under my stool, and that's this way. So we gotta do one of these. See, all this video production that I bring to the table, you guys don't know the sacrifices that I've made. There we go. Nope, that's not gonna get me there. We got stuck on the lower come, there we go. See all this spare mic cable, it drapes down from the mic pack, which is right here on my hip, which is in line with the feet of this stool that don't have anything on them because I slide them around. And so that'll crush the mic cable, and it eventually kills these adapter cables that I use to plug in my mic pack. Why a mic pack, bother? Why don't you move over to a wireless mic? Engage the 21st century. We have this technology to allow you to walk anywhere you want. I'll tell you something. The bathroom is over there, and I do not want to bring my microphone with me to the bathroom. As much as some of you freaks would love that, I'm not going to partake in that. So this is, by all means, a safety measure to keep the kind of content that I don't want to perpetuate off of this screen that we share. Okay, that was uncalled for. That was uncalled. You just activated the fart machine when I was talking about going pee-pee. Okay, that was a lot for us to tolerate, and I want you to know that everybody feels bad for you. They're not mad. They're not mad at you. They just feel bad. They feel bad. What's up, Murderbites? The author's culture and upper, yeah, I suppose, but it's just a, you know, like I'm here writing for the Outer Limits, and I'm gonna make technology bad. Like, can we get a story where it's good? That's sort of what was refreshing about the utopian future of Star Trek. Although it was a little, Star Trek early seasons are so preachy. It's so preachy. Did you know George Washington had cardiovascular troubles? It's true. When they asked about the cherry tree, he said, "I cannot tell AFib." Afibrillation, which is a heart thing. Did you guys get it? AFib is like a heart irregularity, so it's George Washington's "I cannot tell a lie," but they changed it to AFib. It's good writing. The original Outer Limits was so good. Yes, it was indeed. I never watched the show. I think I saw like an episode or two of it, but the remake or whatever it was, the like 90s, was it 90s? I forget. The Outer Limits like redo show. I didn't want to just say whatever, the Twilight Zone, because that's too common. Too common. The scary door. All right. What are we doing? We're going to do some filter stuff, and we're going to see whether or not my scope can justify the expense. I bought the scope early as a birthday present to myself. I bought it when it was like first released, and so it was like $1,000. Turns out it's like a $600 scope, and I probably for my $1,000 I could have waited a minute and gotten the really good version of this scope. But I watched an hour and 45-minute video about the scope to learn the stuff that it does, and it's all fairly common. It's all fairly intuitive. It was just nice to see it all and learn how to control all of it, so we can characterize some of these filters that we've built and actually get them to work, so that I know that they work, so they can go into the main synthesizer. The 90s version had some good episodes, but I like the vibe of the black and white era ones more. Yeah, I mean, Twilight Zone and Outer Limits in black and white is just like, that's how it is. Like, I don't imagine color would bring anything to, because those stories are just, they're so well framed in that sort of visual acuity of, you know, old sets and old, it's just so much, I don't think that's nostalgia talking. I think I like the artistry of it having limitations. The Electric Dream series from PK Dick has been a fun sci-fi episodic show. Well, that's cool. I should look at that. I should look up that. I've just been in a Star Trek slump. 8 or 10 episodes on Prime. I've been meaning to watch the one that was inspired by the Swedish artist that does all those crazy machine drawings and stuff. It was very much like Generation Zero. But the funny thing about Generation Zero is they did not have that artist helping them with the, what is going on down here? Helping them with the visuals. And in fact, that artist was literally across town. They could have consulted him. He was like, I really wish they had talked to me. Making Generation Zero is from a little while ago. It was one of those, it's a Swedish made game where you fight giant robots in the woods, in the Swedish woods, trying to gain back an island that's been taken over by big robots. And they had a lot of cool stuff going on in that game, where there were actually like fuel harvesting robots and stuff. It was fairly limited. It used the same engine as like a hunting game, and so you had these big dinosaurs trundling about, but you could also see them like pushing down the blades of grass as they went around, like stuff like that. And you know, good atmosphere and a really just fun concept. It was a very cool game. I streamed it before, actually. It's called Generation Zero. It's a good co-op game. But we've beaten it 10 times over, and love it. I think there was a DLC recently that was released I should check out. But I absolutely adore the atmosphere and sort of what was going on in that game, and the art of Stellan Skarsgård. No, that's not the right name. I forget the Salon Key Filter. Bah, this memory fails. Yeah, it's Generation Zero. You played it, yeah, it gets pretty difficult. Yeah, it gets a little grindy. All right, we should get started because we got enough to do today. Now that I can see a little bit of my desk, I'm suddenly filled with all of the hope and determination that I can ever imagine, that I can ever muster for this kind of thing. Actually, we've still got a little bit that I can manage. a little bit of nonsense that I can linish back here. A little bit of nonsense. The other game that I was talking about earlier was Approximately Up. And man, that game looks so cool, and I'm so reluctant to install it because as soon as I do, I lose 300 hours. It is so cool. You build a spaceship and then you go use the spaceship to do little cargo missions. It is, it's a little conceptual. It's about as a little bit more sparse than even Generation 0, and Generation 0 is a little sparse in terms of the loop and the content that it does. But the cool thing about the gameplay loop is that you build this ship. You put the engines on it, you put the structure on it, and you wire it. And that's the part that I'm really like, ooh, that's going to hurt me. I'm the type of person who will hyper-focus on building a circuit board because it feels a lot like Factorio, where you're moving signals along these little belts, aka traces, in order to get one thing working and another thing working. If you like Factorio, you might want to look into electrical engineering and building a circuit board. It's called Approximately Up. And so in Approximately Up, it's a little different. This taps into the other part of electrical engineering that I studied, which is control systems. If you want to go up, you can turn on a motor and you can have granular control over the motor. You will go up. Do you want to reach a certain acceleration, or do you just want to squish yourself into a pancake? If your motor's powerful enough, maybe you hit that lever and you explode and you go straight up and you get squished into a pancake and everything sucks. So what you do is you decide on what amount of acceleration that you want, and you put a sensor in there that senses that acceleration. And so you go that number of acceleration. What a control system does is it says, oh, we're not accelerating at all. I need to put an infinite amount of thrust in order to get to that acceleration number. And so it does. You get an infinite amount of thrust, your acceleration goes up, and then suddenly your acceleration is equal to your predicted acceleration, except you have just put on a giant rocket motor for a certain amount of time to get you to that number. You stop the motor because suddenly they don't match up. Motor stopped. The acceleration begins to go down, but not after overshooting the number that you wanted to go to. And as the acceleration goes down, suddenly you are lower than that number. So what do? You turn on the rocket engine again, full blast, let's go. Well, now you're too much. Now you're too little, now you're too much. And you go blah, 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 down to the line. The discipline of control systems takes in a couple other factors. If you get the derivative of the change of acceleration, if you take those numbers as an error percentage of where you need to be versus where you want to be, and you feed that back into the controls in order to pump the brakes on that sudden proportional, let's shove all the acceleration we can into it, then you start to get slightly more intelligent about how you approach that number. Do you want to slow way down and approach it very gradually? And oh, now we've reached the amount of acceleration that I want. And you can do that with position, and you can do that with velocity, and you can do that with snap and jerk and pop. Those are all the derivative, the change of acceleration, the change of acceleration, and the change of acceleration are defined with the terms snap and pop and crackle and shit like that. In case you're not aware that Stream Starts Soon animation is playing. Somebody's always got to try to take the wheel. I'm looking at a monitor. I know. Yeah, I don't know if they were named after the Rice Krispie Treats guys or if it was the other way around. I don't know the order of Beyond. I know Jerk's in there somewhere too. So, anywho, the Moonlander arcade game made us do that with one button and a joystick. Yeah, that's what people generally do in the game Approximately Up. But the game Approximately Up also gives you some math functions. So if you know control systems and you know PID, proportional integral derivative controllers, a little bit, you can implement them in game, and you can do it experimentally, and it might be a lot of fun. I was thinking about getting the game just simply to test that out and just have fun making like terrestrial craft that do that kind of stuff to remind me of all the principles of the control system math that I learned in college. I have a degree in motors and controls from Drexel University, so the hardcore math engineering of rocket science. But it would be kind of fun to remind myself of all that stuff. Maybe, maybe there might be some trauma in there as well. Anyway, we gotta get filters running. So let's get the Start Soon out of here. Let's get the music out of here. Much to the behest of the people who don't know how I run my stream. I know it's confusing, but Start Soon means that we're not working on the thing that's in the title. Start Soon means that I'm just sitting here chewing the fat with you guys, talking about control systems, which is far from what we're actually working on today. Today, we're working on music stuff, so all this stuff doesn't matter, right? Wrong. It matters a lot. All this control system stuff that I'm talking about applies directly to the feedback that we use in the operational amplifiers in order to turn the volume up on all of our stuff. You can make filters with that, and you can, feeding the audio back into the filter is how you use these filters, but it's also a control system, and you need things like Bode plots in order to make sure that your amps are stable at certain frequencies. Now, we're not going to get that deep into it today because this is music stuff and it's Friday. There's a ban on math during Fridays, right? No, what we're doing is Eurorack stuff, and we're going to wait for that to expire before I talk again. I need like a warning light on that. If I put the Twitch page up, the Twitch monitor page, then I will know about that. Listen, the reason that ads are on... Oh, I don't need to talk to you guys about that. You're the ones that paid. Are we starting a little earlier today? Yeah, I started a little earlier. We've got a lot to do, and I wanted to get through the intro quickly. Euro Truck. Well, actually, Murder Bits, for Euro Truck, you haven't seen it, but I got a little something going on for that. I'm moving the steering wheel project with an actual BMW car seat, BMW pedals, and the Mercedes wheel. This I haven't touched in a couple weeks, but when I get back to it, I want to start building up a shelf on this side. There's basically an armrest with the shifter and then buttons and stuff here so I can directly reach them. I might build it a bit like BMW, where this entire center console tilted over a little bit. But I have to negotiate all the rails. These were far too big and strong for this project. I should have probably gotten some slightly weaker rails. These would have been good for just the bottom piece, which needs to be kind of a rock. But for this stuff, this whole gantry piece here, like I could park my car on this and it wouldn't move. But this is a whole bunch of frame rails and then my brother dropping off an actual electric car seat. So one cool thing that I would like to do is give you guys control over my seat position while I'm doing something like Euro Truck Simulator, some kind of like tear-jerkingly boring task in Euro Truck, and suddenly chat's trying to fold my clothes while I'm still wearing them. I just ordered my first major PCB design batch with assembly. Oh, wow. I hope I only have minor screw-ups. Well, I was talking earlier about my minor screw-up on the PCBs that I just got made for a powered multi, and two symbols in the schematic were flipped, and so I thought one bank was the other and one bank was the other. So while everything was perfect on this, except for the footprints of some of the capacitors, I used tantalum caps, which is kind of you really shouldn't do. You shouldn't use tantalum capacitors. They're very specialized and they're very sensitive. They're sensitive and weak, like a Trump supporter. And so they blew up. The tantalum caps almost started a fire. And I wanted to use electrolytics, and the pads for them were too small. I tried to put electrolytics in the design. I wasn't able to do it, so we're stuck with those pads. But the powered mult, I did Seed Studio, which I really like the quality of the Seed Studio boards. It was like $30 to get this made, which I would absolutely dump another $30 into. But then there were tariffs, and there was shipping, $27 in shipping. So this ended up being like $70 when all was said and done. So if I order more boards, it's going to be another $70. I got to be careful about that. All right, we're back. We're back from the ad break. I was just lamenting my circuit boards and showing Murder Bits my sim setup that we haven't worked on in a while. But we'll get back to it. All right. I forget what I was talking about. I was in the middle of talking about stuff. Eurorack. Synthesizers. Electrical test equipment. Electrical test equipment started in telecommunications, in 19-inch racks. And those 19-inch racks were split up into small sections, horizontal positions. Eurorack looked at that and they said, that's cool. Our synthesizers have a whole bunch of like shared functionality parts. You have something that makes a waveform. You have something that limits the waveform and filters it. You have something that controls the waveform. You have something that controls rhythm and stuff like that. All of those functional bits, they turned into what originally was 19 inches wide, but the horizontal positions are sort of the size of the Eurorack. I have a piece of test equipment back there that's a Tektronix. It's like a universal test equipment thing. and I got to get rid of it because it's too big. But the temptation would be to take all of those test modules out of that because they are Eurorack sized, and I could use that as a modular synthesizer rack that goes into a 19-inch rack. Problem is, it's like huge, it's really deep. It's a very deep thing, and it's extremely heavy because it's got a big power supply. So I'm not going to be doing that. But Eurorack said, whoever made the standards for Eurorack was like, well, also, you know, all of this stuff would benefit greatly if we had a positive and negative voltage feeding everyone. So digital electronics be damned, we're going to use plus and minus 12 volts. They said, well, we'll start at 15, we'll make the maximums 12, and then our signal will be 10, and then the control signals can be 5 or 0 to 8 for trigger signals. It's all over the place, but the point is everyone can be hit with that plus 12, minus 12 volts and not blow up. You're not going to destroy your equipment by plugging something in wrong. And they said, hey, we could also use 1/4-inch stereo cables because these things are cheap and they're pretty good at bringing a signal around. We can put a ground on it so that it's shielded, and so you can have cable runs that go all over the place. You can configure the topology of your synthesizer any way you want, right? So that's Eurorack. Eurorack, you got a 15-volt supply. It gets turned into plus minus 12, sent along the way, sometimes 5. And everybody just is in the same walled garden. You can do no wrong. Cool. So that's Eurorack. I got into Eurorack because you can just buy the circuit boards for these things. People open source their designs, and any variety of electronics complexity and design can be bought as a bare circuit board. So something would arrive, maybe it would look like this and have no components on it at all. And I can sit here with my brain turned off and build these things up. Now, what I've learned from doing this, quite a substantial amount, believe me, what I've learned from doing this is that the designers of these boards will sometimes have parts that they really like. And so they'll have a lot of these parts that they really like. And some of them don't know a ton about PCB design. Listen, if these people can build these absolute cretins, these subhuman module designers, the people that build stuff like this that deserve none of your pity, the reprehensible, absolutely terrible people that build circuit boards and get their channels printed on it like in a URL, awful, terrible, horrible people sometimes don't really know a lot about circuit board design. And so you see a variety of different board designs at play, like people who use a program called Topor, which should be outlawed and does just it does as the crow flies trace routing. It doesn't care about aesthetics, and I hate that for it. I hate that Topor does not care about aesthetics. I do love the level of Australian trolling in using Topor for every design that nonlinear circuits does. I appreciate that very much indeed. Yeah, what do we say? What's chat? Hold on. So I'm trying to rage bait you guys, and you're not even talking. I just ordered my first major PCB design with batch assembly. Yeah, that's okay. I talked about screw ups. Is there a good solution within the Eurorack ecosystem for handling different power requirements? If you need more power, no. You may have to have an external plug, and Eurorack does not provide a lot of power. This is why you don't see vacuum tubes on a lot of your Eurorack stuff. You know, the temptation to have like a tube amplifier on your Eurorack modular device is probably pretty great, but then you realize that tubes that like a triode needs 60 volts in order to operate. So you are under your own devices for making some of these voltages. And in fact, a lot of people use the 10-pin power connector instead of the, 10, 11, 12, 13, 14, the 16. There's a 10-pin and a 16-pin power connector. The 16-pin has 5 volts right next to plus 12 and then negative 12. So it's 6 ground, it's a lot of ground, and then you have minus 12 and plus 12. And people don't even take in that 5 volts because they just convert everything to their own voltages. They use LM1117s or a 78L05 in order to just, because 78L05 is weak. This thing sucks, but it's enough that we can power up all of our op amps to their voltages and they can manipulate voltage levels. That's all we're doing. We're not doing any work with these signals. So if you've got a big hungry like LED display, or you've got a vacuum tube that you want to use, you've got a vacuum fluorescent, a VFD, a vacuum fluorescent display. There we go. I got there. Then you are at the mercy of whatever amperage is coming in, and you may not be able to use that special part without like having like a plug, like an external plug on your rack device. It's generally frowned on. Why would you put plus 12 and 5 next to each other? Well, I mean, how far apart can you make them? What you want in this connector, and what I mean, mostly plugging in this connector is the biggest downfall for any of these modules, but what you do with this connector is it's totally symmetrical now. So they got rid of the 5 volts at least, but they've got plus and minus 12 volts on the two ends, and then in the middle they got ground. Plug it in the opposite way, you've got suddenly a 24 volt difference in what's actually supposed to be there. You put a couple Schottky diodes in the current path, then the diodes will protect you. So that's a lot of the logic behind that. But then, like, if you plug that in backwards, it's short out. I don't know, man. You got to get power in, so you just use a regular old header, a nice IDC cable header, and everything works out. And at the time, that was totally reasonable to do. We didn't have a lot of the, XT connectors didn't exist back then. And these are supposed to be keyed, so you're not supposed to be able to plug them in backwards. But anywho, so that's Eurorack. I thought I would just explain Eurorack on a basic level. What it means is that we can take a control signal, we can plug it into a module and create a waveform. And then if we want to listen to that waveform, we can attenuate it, make it smaller, really small, offset it, and put it out to a speaker. But all of this stuff exists within its walled garden. And if I plug an audio signal into a control signal, this thing will just flip the control up and down as fast as it can. The whole purpose, well, not the whole purpose, one of the things you do with Eurorack is you make cool synthesizer sounds, and if that synthesizer sound requires you to do something like this, you put a control signal on that so you don't have to sit there and do this. So, one of the main features of the, wow, this is, ooh, I gotta like deep clean that, holy shit. Anyway, I haven't had this part of the desk blank in a little while, and we've been doing a lot of soldering. Remember when Apple put the 1.8 volt CPU rail and some higher voltage rail for the display right next to each other in some very small pitch connectors, and some pieces of dust caused it to fry your CPU? Wow. Well, okay, so Apple always kind of pushes the forefront of design. This is old power requirements, and so putting stuff next to each other, that's up to how you're designing things. We use giant connectors for that reason. Like, we use the old technologies. What was the post that I saw? Like, get with the times, use AI. It's like, bro, I'm happy being left behind, man. I'm sending emails with a PlayStation back here. Like, we are happy to be left behind. 0.1 inch headers are great. They're so far apart that we can clip scope leads onto them, right? Whereas you get things that like Apple designs, and while it's like amazingly professional, all of the parts are 0402 sized, and it's like impossible to see what's going on. You can't troubleshoot it. But then again, it's all digital. We're in the analog world, man. So like this stuff, how do I solder that? I need a robot arm. I'm not doing that. This is an Apple. This is just a random Samsung SSD from like yesteryear. 2015 maybe. But like, no, we don't do that. We do this. It's much bigger and it looks cool, and then we write stupid stuff on the boards like what's the little phrase on this one? Delay no more. There's usually a little quip on it somewhere. I think this one's who wants to die for their art. No, not seeing it. Huh. I thought there was a quippy little thing on here, but maybe it got covered over by the ICs. He's usually got some weird phrase on them. Nonlinear circuits is awesome. They put out like a module a week, and a month, I think, and there's all kinds of crazy principles behind them, academic papers and things like that. Very smart guy. Uses Topor router, and I hope he goes to hell for that one day. But other than that, everything is kind of cool with these circuits. They're just sort of a little lackadaisical and unserious, and they do cool stuff. Still trying to reverse engineer the firmware on some of my Chinese MCUs that mostly have a Chinese datasheet. Oh God, that sounds crazy. The thing that I wanted to do that was like that is I have type 1 diabetes, right? You probably already know this. You probably already know that. I have type 1 diabetes and I use Omnipods, and the Omnipods are disposable insulin pumps, and they're not that disposable. You dispose of them, but they're not that disposable. They've got a circuit board that's worth about $30, and they've got a microcontroller, and they have an RF controller on it as well. RF controllers are typically just microcontrollers with extra stuff. But the microcontroller itself can run a piece of memory wire in order to pump the insulin. And so that microcontroller, I've got a bin full of them, and I've got another bin that's full of pumps that I can process into just microcontrollers. I was hoping that I would be able to get into the firmware. It's a Freescale semiconductor chip, but it's a custom chip. So it's probably based on one of their platforms, but it has, like, you know, a MOSFET output so that I can run that memory wire. I do not know how to even approach getting into that digitally. It's probably doable, but not for me maybe. And so I've kind of abandoned it because it would be funny if I had the Oh Bother microcontroller platform, which was literally a microcontroller that kept this weird streamer guy alive for 2 days. This made it so that he could eat a cheesesteak. And now it's powering your project. I managed to find some on Alibaba to test, but only was able to buy them in 50 quantities, so now I have 50 of them. Can I just ask, like, why would you do that to yourself? Why are you doing this? Why? What is the benefit when you can get an STM32 for $1 and it can do your math homework? Like, you know, like at a certain point, you don't even have the story that it kept a diabetic alive. So why are you doing this to yourself? I guess so you can do it in the future to other stuff and you get stronger and smarter and cooler. Hold on, I gotta adjust my mic. Okay, but I mean, like 50 for $5, but you still got to do all that work. So was it really $5 or was it all that work? What is your time worth? The goal is to build custom firmware for each solar inverter. Oh, I see. So they aren't tied to Ali Cloud, and I'm able to run them locally. I F with that. That is a noble pursuit. That is a noble pursuit. Oh, I was saying earlier, the powered multi that I have. Multi is when you plug one plug in and it powers these with something that's got oomph behind it, so that if you put splitters on your lines, your voltage levels aren't getting altered. If I was going into a voltage controlled oscillator, it's 1 volt per octave, and so each of those notes are actually a fairly sensitive voltage. So if I plug into the unpowered multiple outputs, it might be off key. So you have a powered multi, and I thought that would be a cool little two horizontal position project. And in Eurorack, a lot of the time, not always, we use what's called a Thonky Con connector, and that's a renamed specific type of connector. I don't know what the part number is right now. You can pull it up on a site called thonk.co.uk, and they sell these and call them Thonky Cons. It's their fault. But the Thonky Con is a really good connector because it is the exact distance as the alpha potentiometer. So you get a really nice feeling premium alpha potentiometer. These are knockoffs actually. And then you have your Thonky Cons, and then you have something like indicator LEDs of your choice, or you use something that's impossible to find. I'm looking at you, Emily Gillette. Why did you use this stupid thing? I hate these. These are like $7 each because they're rare. But 3mm LEDs, plenty. 10 kilo ohm potentiometers going into a digital thing. All of this stuff has a same height, and so all of it can mount to a panel and go in line with all of your other Euroracks. This is a little off-putting. This is going to be my module testing module. It's all I've got right now is this test circuit that's able to make a couple frequencies that are relevant to Eurorack modules. I'm gonna gussy this up. It's gonna look a lot nicer in the future. It's gonna have more features, gonna be able to self-test. But for now, don't worry about this. we're talking about the good looking modules over here, right? So you put all this stuff together in your walled garden, and you can then have what is called, well, this is a clouds filter. I kind of want to look at this one today, although that means starting up Fusion 360. I kind of want to look at clouds and figure out what was wrong with it, because we've got some functionality out of this, but not all of it's working. And then the other one is the nonlinear circuit series filter. These two potentiometers, I didn't touch them. I literally just gave this over to Julian and used this for the last couple streams of where we were making like sounds and stuff with it. And it's a really cool filter. It's totally unhinged and it'll squeal and damage your eardrums. But I kind of want to make sure that this thing is tuned up. So let's get to some of this stuff while we're talking with the chat here. What's also funny is the MCU I'm working with right now is a clone of another very Chinese. Oh, really? They're self-cannibalizing. So with the powered mult that I was talking about, I wired this up, but I got two symbols wrong in the schematic. I had two input jacks and I had one over the other. And so the one on top, I routed to my second bank, and the one on the bottom, I routed to my first bank, because then all the lines would be clean, right? All the lines would be clean. And then I put the circuit together and I organized it so that the jack on top was up here and the jack on the bottom was down here, which means that the outputs for the outside of the drawing were on the bottom. If you haven't noticed, they're crossed. So there's a little switch inside of the jack where when you plug in a headphone connector, it disconnects that little switch. And so that gives you a little spring on the end of the plug, so it holds it in there with a little bit of force. And it holds it against the ground. So that one connection gets broken. And so if you wire the connection that gets broken to the input of one of them, and then you wire the other one you just crisscross that, it means that if you plug in either of the inputs and another input is not plugged in, it'll go to all of the outputs. So if I plug in here in the middle, it'll go to all of the outputs. Problem is, I wired up, this one is supposed to be this one, this one's supposed to be this one. So while everything worked, if I plug into the top bank and I plug into the bottom bank, the top bank is the bottom three and the bottom bank is the top three, which could be fun. That could be whimsical and fun. And then I could just build the boards and I didn't make a $75 mistake and I don't have to route and rip up traces. Nope. I have to remake the board, because when I was doing the runs of the connections, the chips are behind each bank. And so I went to the thing and then I went to the thing, and it turns out I can't just rip up two and flip them, because in the middle is the output. It just messes it all up. Just try to fix the traces and cut them up. I did that with this one. We got it to work, but that's going to cause all kinds of pain. So I'm just going to have to reorder the boards. It's an expensive mistake, and these are all coasters now. I'll hold on to one or two examples and put it in my drawer of circuit boards, but version 2 is in the pipe. All right, you know what? I'm going to start up. I gotta know what's wrong with clouds. We were gonna try to do a little bit of characteristic filter testing and see if we could, I could do bode plots on these. I have some Python 3 code that will actually use my oscilloscope in order to create a bode plot from a square wave going through a filter. It's kind of badass, but I'm not even approaching that. I could do some frequency, some fast Fourier transforms, and then use persistence in order to characterize the feedback from a filter. I should probably test that a little bit on my own first. I think what we should do is we should go through clouds and see what's wrong with it. I don't know specifically anything about clouds. I don't know what clouds does. I don't know how clouds sounds. But what I know about clouds is that you put right and left channel audio into clouds, and it will have a left and a right audio output after doing some stuff to your sound. The stuff that it does, it uses a DAC for digital to analog and analog to digital. DAC and ADC are terms that I constantly get wrong, but the DAC and the ADC are little codec chips that are on this. We have a big old STM32 that I've programmed. We have codec chips and op amps. Now with mutable instruments, these are made for professionals. There are remixes of these designs, and because I'm shopping from Modular Addict and not SynthCube, which was my first mistake, I bought the professional ones. I kind of wanted to anyway, but they're kind of annoying to work with and they're old. We can't really see the traces here. What we can do is open up Fusion 360, which I will do right now, and we can open this project and reference the design to the schematic, because Emily Gillette pieced out of the modular scene. She said, screw you guys, I'm done. And like a saint from on high, bequeathed, I don't know, man. She gave us all the designs, which is absolutely amazing. I would love if we had notes as to why certain decisions were made. Suspend Fusion on, I don't even have it open on the other computer. It crashed. Suspend Fusion on the other computer, select below, continue on this one. Yeah, let's do that. Yeah, I guess that was before the storm. I saved off all of my stuff, all of my edits on the version 1 of the thing. I could try to get a CT scan of the PCB at my university. That's actually a very good idea. I don't know if you need CT scan. Do you guys have a 3D X-ray? I used one of those when I was working at the FBI because we would get circuits that were protected against the elements pretty heavily. And so going through there like an archaeologist with a brush and a chisel is not going to happen. It takes way too long. So a team adjacent to us got a 3D X-ray, which is just an X-ray on a stick. But it's this giant lead-lined box that costs more than my house. And we were able to do little flybys of the chips. And you could see everything that was connected in there. It was fascinating. Some really cool stuff. Or go to a vet, maybe a veterinary hospital, and tell them that you got shot by a gun. And when they're about to scan where you're pretending that you got shot, you quickly throw the circuit board in there. A look into the future of fusion. Hey, I don't want that. Go away. Oh my God. Yeah, all the fusion warnings are for unsupported version. I've got Windows 10, which is apparently like illegal or something now, and everybody wants you to have Windows 11, and I completely refuse. I refuse. You will tear it from my cold, dead hands. Bad enough that I got to use 10. All right, let's do that so you guys can just see the whole window, and let's go to mutable instruments. Why is this like chugging? Okay, it's getting its bearings. Okay, so here are all my modular synthesizer projects. One of the things that Emily Gillette has done is exposed all of her designs on GitHub, and so you can actually get these and load them up into Fusion 360. So somewhere around here we're going to have clouds. So somewhere there it is, clouds. And so what I can do is open up the electronics project for it. This is my front panel design because I'm doing that myself. But we've got a version 30. I don't know why I have two of them. We have a PCB and a board design, a BRD and an SCH, a schematic, and a BRD, a board design. You're working with SolidWorks? Yeah, I use Fusion 360. I'm also sponsored with a Fusion 360 copy because I used it. They saw my stream and they said, hey, we're willing to give you a free copy if you do a couple hashtag AutoCAD ads. And I'm like, look, I use it anyway. Drexel University taught me to use it. And so I didn't use CAD for like 10 years after that. And then when it came up to design circuit boards again and get back into that, yeah, I was like, well, what do I use? I know Eagle CAD, and it turns out they were bought by AutoCAD, bought by the SolidWorks people. And so Fusion 360, while it's also a free program with limitations, it has circuit board design in it as well as three-dimensional design. So it kind of took some time to get to know both pieces of software, and they work together. And so you can design your circuit and then jump straight over to making a front panel for it if you're doing Eurorack. Pretty cool. Yeah, KiCad and then FreeCAD and all that stuff, they work, but there are weirdnesses to them working, and there are weirdnesses to every CAD. You have to kind of learn your CAD system. And if you're an engineer, if you're looking for that engineering degree, you have to be able to jump from CAD to CAD. It's like having two left feet when you jump CAD, but I can still do it. I'm just a little limited on some of the things that I can do. All right, so what are we doing right now? Well, okay, clouds, as far as we know, is broken. I was unable to load custom software onto it. I've been unable to use it as any kind of a meaningful filter. When I put a signal into it, there's a little bit of feedback in the forms of the LEDs turning on. but the outputs are not working. I could do a CSWP certificate for SolidWorks at my university for free. You'll get the same copy that, well, I guess you get an educational copy of AutoCAD. I don't know what's with the educational copy lately. They've added some features to it. I think that's so that they can be a little bit better about people getting university copies of their software, you know, kind of limiting their usage, because I think a lot of people were getting it that way easily. I think if you just have letterhead from the university, that works too. Anyway, so as far as I know at the moment, signal inputs to clouds are not working properly. What I can do in Fusion is I can take a look at those signal inputs. So this is Emily Gillette's original design with all the original parts. All of these things, all these components are actually associated with a two-dimensional footprint. So when you're building the schematic like this, you make it neat and organized so that anyone reading can come in and look at it and say, oh, I know what that is, but that's not actually what you're doing. What you're actually doing is you're programming this piece of software to know that this connection here goes between these three components. And so what I can do is I can actually just click on that trace right there, and now I can reference that to the two-dimensional board design. Highlighted traces are that connection. So blue is for the top layer, red is for the bottom layer, and the stuff that's selected is what I just clicked on. So that's that connection right there. And that's just grounding a local area. We unviewed the ground flood fill, but yeah. It's graph structures all the way down. One thing, the most important thing when you're doing a layout like this is to make sure you coordinate all your parts and make sure that they're all designed within the same sort of grid that you're going to use, because otherwise you'll be in tears. Nothing will line up, or you just free yourself and you use topor and you become like the airbender that never touches the ground. You're just free of all of the worries of modern society. Setting up your grid is like super important. Like a grid of 1 millimeter with like a 0.5 millimeter spacing is decent. I usually use what is this one set for? Oh, it's something crazy. That's probably because I haven't set it. I usually do like 1 millimeter and then, or no, 0.1, 0.001 millimeter. That usually works pretty good with a lot of stuff. And then you can get your mill spacing set up so that your manufacturer of the board won't be caught out and, you know, won't have to tell you they can't make it because everything's too small and close together. I like to use interactive HTML BOM when assembling PCBs by hand. I do this. I use this because I will just go through like, oh, what am I installing? C7? Where is that? Where is R40? And, you know, going through a bill of materials is nice too at the same time. But, oh, there it is. Okay, that's where that is. I'll put that there. You know, that's how I usually do it. Anyway, so we need to troubleshoot this thing. So we need to actually get to the other pages of the schematic. How do we do that again? Sheets. And then this sheet, this one has some of the inputs. So the one that I'm interested in is starting with is the right and left inputs here. So the right and left input here goes to R58, and we'll pick it up at R58 and R57. So this is our stereo input, and we're going into an inverting operational amplifier circuit. What this does is references your voltage level to ground. That's what an operational amplifier does. A triangle on its side like this is an amplifier in schematics. An operational amplifier has two inputs, a plus and a minus. So if you hook the plus up to ground, just do some psychotic thing and hook it up to ground, and give it a voltage level on the minus, you are into the transfer function, you're putting it into a negative, and the op amp has like a gain of something around 300. So you're going to get some blisteringly cut off signal on the output. So if you put in like a tiny little signal, this will bump it up to huge values. In order to keep that from happening, since this is coming out of the operational amplifier as a negative voltage of whatever the input is, you can loop it back around and put it back into the input. And so you've got that negative voltage tamping down your positive voltage or whatever going in. And think about it that way, and suddenly that's a transfer function. That's a control system. That has eigenvalues. That has stability. That has, it's like, suddenly the math is crazy, right? So, but that's how we amplify audio signals. I mean, we've got something that's snappy enough like an amplifier, an operational amplifier, and we feed it back into itself. And so this control here, this PV112, this super duper annoyingly expensive and rare potentiometer that Emily Gillette decided to use, it's a dual gang pot, so these adjust together. What this is doing is this is allowing more or less current to flow through the filter feedback and tamp down our output. The transfer function is a simple equation. It's the output is equal to the input times, what is it? R2 over R1 with, I think this is R2 over R1. And so we're altering that equation with a potentiometer and changing the amount of resistance that's going through here in order to provide more or less tamping of the signal. Whew. Currently preparing for your controls engineering exam. Have fun with it, man. That stuff is literal rocket science. I had to learn how to program the TI-98 to within an inch of my life in order to function at all with that level of mathematics. So let's power this thing up. We know that we're basically going to this resistor right here, and we can follow it along the way to make sure that whatever comes into this thing is coming out the other end. Whew, that was a lot. Listen, I'm trying to be more basic. Oh, I missed the button. I'm trying to be more basic. Bother, you're so basic. I'm trying to explain this stuff on the lower levels so that people know what I'm talking about. The audio nerds follow along instantly, right? But yeah, Laplace and Z transforms, LTI systems. What was the LTI again? I remember the Laplace and Z transforms, though. Not to say that I remember them, but I know I learned them at some point. Linear time invariant. I see. Yeah, linear algebra's a beast. It's a beast, but it's so powerful. If I knew the stuff that I knew about physics with linear algebra when I was in my basic high school physics classes, I could be doing all of the multivariable calculus in my head. Burping a little bit. I had something very oily for lunch. It was more of that spread. All right, what is our setup going to be? Let me think about this for a little bit. We can't have a front panel on this because we have to poke at the circuit. Can we suspend this on a circuit board holder and still plug it in? This has a lot of depth to it. Because we need to poke the oscilloscope into this thing in order to see all the stuff doing stuff. Nope, that's not enough. Okay, so we are going to actually use my new circuit board holding setup. This thing is cool, man. I don't know. I'm still learning to work with it. The little duckbill holders, they hold things very high up, but it's sometimes good to have that. So I think we can get in here, and I'll just get in here. Try not to block too much because we're looking to see the soldering on this, see if my soldering's up to snuff. This will give us a little weight to the circuit board, and it'll make it so it's something that I can push down on. Yeah, like, see, that's not moving. I'll have a potato carrot stew for dinner. Hell yeah. Hell yeah. I made a spaghetti sauce the other day. I have a bunch of tomatoes from the garden. I decided to just kind of throw them together. And I don't know what the pepper is. It's like a cherry pepper. It's like an Italian pepper that's pretty good. And I threw that in there, and it was smoked with cherry wood. So cherry smoked pepper on like an Italian sauce. All right, so here's why we know it's working. We know the microcontroller's communicating because, oh, you guys missed it. You guys missed it. We know the microcontroller's working because when I turn things off and I turn them back on, do-do-do. So it wouldn't be doing that without a microcontroller participating in the whole equation here. So we know that the microcontroller itself is working, but when I take something like a sine wave, and let's get the scope in on this too. So I take something like a sine wave, which, believe it or not, looks quite a bit. Hold on, let's get this into the powered multi. I got a couple cables here. We're gonna have to be kind of careful with them. Okay, sine wave here into the powered multi. That gives us a whole bunch of sine wave outputs. And so we can look at the sine wave on the scope. Where did you go? Oh, there it is. There's our beautiful sine wave, plus minus 5 volts. Zoom in a little bit on that. That's not it. Zoom in. Oh, wrong channel. Channel 1. There we go. Okay. A nice, clean, family-friendly sine wave. Nothing weird going on. Nothing too challenging. Good, clean fun. And then we take that sine wave and we put it into clouds. And so I'll put it into, all right, what's clouds? Okay, let's start with the left channel. In left. I don't know which one's which, so we'll just in left, boom. Now we have an input going into clouds. If I turn the volume way up on clouds, which is the dual gang potentiometer right here, either way I'm moving, I'm not getting those LEDs. They're not doing anything. Those LEDs ain't doing nothing. Do this so we get a good view. Okay, so this is where things get fun and cool and interesting, right? Right, kids? I've got the blue trace over there, but what I'm going to do is I'm actually going to take the blue trace. I mean, if we look at our output too, there's nothing on the output. Nothing doing. No volume at all. And that sine wave should be going through. The sine wave is 65.4 hertz, which I guess is a C something or other. Yeah, it's probing time. Time for probe. Okay, so now I'm actually, let me get my channel probe over here. Yep. And we're gonna follow this through the circuit. Follow it through the circuit, see what's what. Do you have any stereoscopic microscope? I don't, but the ones that I would really like to get, and you can find them on eBay, and I don't know what the prices are like these days, but there's ones from, oh damn it, I forget the company name, hold on. Manufacturing inspection scope. I should start a company that makes stuff like this. Not boroscope. Fiberscope, no. Harvard University, no. Man, who makes it? Scorpion. No, not a scorpion under a microscope. Scorpio AI. Ugh. I'm trying to think of keywords and they're all, is it Amscope? No. No, these have a lenticular spinning thing inside of them and they're really cool. No, no, no. Oh, is it actually, it might have a different, let's get the product name out of there. 2-eye microscope with spinning lens. Just spinning optics. No, 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 none of these. There's a particular brand, and I can't find it, that uses, are you kidding me? I want normal results. Shoppings, short videos. Why have we done this? Web. What happened to us? Oh yeah, Vision Engineering. Here we go. So from Vision Engineering, they're the ones that you see in the background of a bunch of like sci-fi shows because they just throw these things in the background. They look like futuristic devices. But inside of that little hood is a spinning lenticular lens, and that means that you don't have to crane your back in order to look into the lens. So hold on, let's check to see if they're probably not affordable. Mantis, that's what it was called. Not what I'm looking for. Not what I'm looking for. Not what I'm looking for. Used. Bonk. Boy, does that weed out a lot of crap. That's used. I think they just put that on there so that they would get in the search results. Come on. 1,500 bucks. 600. That's a little better. $399. That's semi-affordable, but you don't get any of this stuff with it. 80 bucks. Bam. That might not be a microscope. Mantis Elite Stereo Microscope for 3D inspection. If you're going to be doing a lot of soldering, these are awesome. These are so cool. And I should just buy one so we can look at it. But man, that price is really, really good. What's the $5,000 shipping? $50 in shipping. So that's what I would be looking for if I wasn't streaming. There are versions of the Mantis you can plug a camera into, but that's a stereo microscope that you don't have little scientist lenses to grip your eye sockets around. So you're sitting much more straight in the chair and you don't get back problems. So the Vision Engineering Mantis is really good. Now I don't know about what zoom levels you have on this, because we get amazing zoom levels on my webcam microscope that cost a fraction of what this does. But I bought a 100 GBE L3 switch for 200 euros this morning. That was a good deal. That's cool. But yeah, anyway, the point is, like, get yourself away from crouching over the little microscope lenses. That thing looks good. It's $175. Oh, that thing looks cool. Anyway, these things are great. I used these at the FBI. They had in their lab, and it has stereoscopic view, so you don't stab yourself with a soldering iron. All right, anyway, we're taking a look at the circuit, and we're trying to trace it out and find our sine wave. So as we go through J8 on P3, we will be able to see on one side of R58, we'll be able to see our full sine wave. So let's take a look at the one side of R58. I should probably put this screen, and just know that this is over here. Stabbing oneself with a hot soldering iron. Why did that? The first thing I read is stabbing oneself with a hot soldering iron, and the idea light shows up. What? Doesn't sound like my idea of fun. Oh yeah, there you go. Well, you know, we can have ideas about fun. Some people are into it. I was soldering LEDs on a giant 6-foot diameter globe, soldering these really bright LEDs, and I'm standing up on a ladder on this globe, and I've got my actual paste soldering iron, the one that I have sitting right here. And in order to have that near me, I was holding it like this. I forgot which end was the iron and which end was the cable. So I meant to bring my hand in to where I felt the cable, and I went, I had a divot on my hand for a month. By the way, Project Hail Mary. We got the soldering iron from Project Hail Mary. See that? That's right. That's the soldering iron from Project Hail Mary. The scene where he's putting together like the map thing. He uses soldering iron, even though it's like welded metal. Doesn't matter. Hollywood's weird. Anyway, clouds is powered. We can see heat on a bunch of our different devices, and it's not blowing everybody up. So I got a Rigol MH0934 2 months ago. Now I'm equipping my lab. That's why I'm looking for a microscope. God, the MH0934? I want to get the signal generator, but it's too expensive. 934. Well, I'm telling you, the AM scopes or whatever they are, the Vision Engineering are crazy good. I should have gotten the scope that has the signal generator, because then we could have had a better time with it. Mixed signal high resolution oscilloscope. Well, that's a lot of stuff. It's got a logic analyzer and everything. The one that I use is the DHO 914. That's what's giving us our wonderful visuals up there in the corner. Actually, let's pull that away from the corner. Let's bring that scope over here. We'll just put it right there, because that's the star of the show right now. You can firmware hack to 1 gigabyte. I gotta look into that. What my 914 can do. I didn't get the 924. I got the 914. But I did watch an hour and 45-minute video on how to use the 924. So hopefully we bounce back and we're able to do some filter characteristics. Right now, we are doing some basic probing. Maybe if we get real good, we can do some filter characteristics. We do a little fast Fourier transform on this and use persistence so that we know, or so that we can view what happens to our signal in the filter and maybe characterize what frequencies it likes. We're not going to do like a Bode plot or anything, but you can firmware hack the 914, the 924. So basically just unlock 50 megahertz on the top end. Pretty cool. All right, there's the scope. I guess we can use the small scope because we were just, you know, basic probing here. But on this side of the amplifier, we get, there's our signal again. Channel 2, we're going to bump up a little bit. So channel 2, dead. Channel 2, scope input. Cool. Those are the two sides of that resistor. We go to the other side of the resistor. R47. We're not really going to, I mean, we're going to just see the sine wave again there, but we'll check. We'll just check to see that we're getting it in all of these places. So R47 right here, this would be that junction. This would be, hello, hello, it's me, your dead signal. R47, what is you doing? I'm not sure if the 914 has the AFG hardware. You can also firmware hack the AFG, the function generator. Does the 914 have that? Because there's a Rigel scope that's also a function generator, and I thought that would be pretty nice to have the combo. But there's also the video that I saw, the guy had a separate device that was a 2-channel function generator. But that I think is like way too crazy. Oh, we've got an ad starting in a minute here, so we'll get back to troubleshooting. How do you have all this stuff? You started off like you were a student. You're preparing for an engineering exam, and you're telling me you've got all the higher levels of all of my equipment, and I'm the professional. Yeah, I can't quite save up for test equipment. Test equipment's too expensive. Nowadays, all the stuff from China is great. You can just use that stuff and do the same things that I'm doing. So, okay, so our channel right now, we're coming into the left channel, and we are going to the R50 and R47. R47 at the top here is doing our sine wave, but tamped it down to something like 1 point something volts. Now, if I turn this up and down, we're not seeing any kind of a difference here. This is probably the other side of the 22 kilo ohm resistor. This right here, or this right here. No, that's our full signal coming in. Is there a problem right here, officer? I think there might be. But then over here, we got our signal. This is outputting on pin 7. So 1, 2, 3, 4. And because these used to be vacuum tubes, we have gap 5, 6, 7. This is our output. As I move the potential, that's the wrong one. As I move the potentiometer, oh, that gets real hot. Our volume knob works. The beloved DHO 914 does have the AFG out hardware. If you look at the back, you should be able to firmware hack it to work. There's an EV blog thread. If you've got that thread, I'd love to see it. But we're in the middle of an ad break, so I gotta wait. Poser, hey, thank you so much for the watch streak. Hey, that is like dangling a carrot in front of me. It's like, hey, guess what happened? A watch streak, and I'm like, oh. Didn't know the vacuum tube thing with pin count. We moved from vacuum tubes over to metal cans, and the metal cans are pinned in a similar way. They'll have like a tab sticking out, but they'll still have a gap. And so you go, what is it, clockwise? That's anti-clockwise from the gap in order to do the vacuum tubes. That went to metal cans. Metal cans turned into epoxy substrates with pins on two sides of the thing. And so when you've got pins on the two sides, you keep counting in a circle. I don't know what you're talking about, but you're straight spitting bars right now. Electronics Basics, this is the basics, man. Happy to have you here to listen to it, because I guess, you know, I've had buddies over here before, like music buddies, and he teaches school, and he's like, dude, you're actually really good at explaining this stuff. And I'm like, well, it's what I've done for a long time. You know, training people in an office and doing this stuff, and just, yeah, being frugal about electronics and just spreading the knowledge. Spread the knowledge like butter. I don't know that I'm good at this, but I guess I am. Okay, what's that? The B dump is from 125 megahertz to 250 with the firmware unlock. So you can hack the DHO 914 to be the DHO 924S. So I get 250. I'm not 125 megahertz. I thought the 914 was, oh no, it is 125, you're right. Oh boy. I don't work in those megahertz though. And I get the auto function generator? Ooh. Ooh. I'm gonna have to hack the Rigel. Rigel does not care that you hack their equipment. They don't care, because the professionals where they're gonna make most of their sales will want their calibrated and certified scopes with the software that they've got. and it's nothing to them to pay for the extra stuff, right? And so that's where Rigol makes the lion's share of its money. But they also sell the scopes in a dinky little cheap version. So you get a dinky little cheap version, and then consumers don't care that your scope is super certified and calibrated. We're just glad it's at 5 volts. And so hacking the Rigol, while it's illegal, is nothing to them. They will not come after anybody. I think they generally encourage it because they have become the hobbyist scope. They're the semi above hobby level scope to get because they're not expensive. They are a lot of money, but for what they are, they're not expensive. All right, we're back. It's fully offline, so how'd they know? I plugged mine into the internet. I have an Ethernet cable plugged into this one. I haven't gone to update it, but I guess maybe the Rigol doesn't phone home as much as we're typically used to our Chinese electronics doing. Yeah, maybe I need to tell the Rigol scope on my router that it's not allowed to get internet. But yeah, well, I really do kind of want to hack the scope. I think that would be awesome. I'm working, but I'm also absorbing via stream osmosis. There will not be a quiz on any of this. Right now we are troubleshooting musical instruments, but we're doing it using Fusion 360's ability to associate parts and open up an SCH and a BRD file. And so we're going through and we're just following where our circuit is going. We're just following where that sine wave is showing up. So yeah, the output is able to kind of cook. It's able to get kind of crazy. That's 6 volts, peak to peak. All right, so left channel volume appears to be working. It's just not like, well, we got to see where it goes from here. Let's try the right channel. Second verse, different from the first. Oh, this has a weird pinout. It's going to be like on one of these. Yeah, there it is. Yeah, the pinout on this thing is kind of cursed. That goes a lot. That's a lot hotter than our other one. Although we might be on the other side of the signal. I'm not sure. Let's just check the output pin. You don't have to do that, but I appreciate it. You can just link me to the thread, and I can sink or swim on that. The output for the other channel. Let me look at the schematic over here. Pin 1. It's this guy right here. We didn't get anything on the output though, so the right channel should be outputting there. I don't know what pin on this cursed potentiometer it is. And then R53, 59, 51, 40. 53 is going to be like 52, 50. Where are you, R53? What are you doing? What do you like to do? R53, where are you going to be? I mean, usually with these Emily Gillette, this is a different control. So I guess this would go to an op amp that'll then meet up with a negative 10 volt source. Now, if you're wondering why, like these are crazy circuits and they're a little bit complicated and there's all kinds of weird stuff going on. What we have right here is a way to implement variable gain using a potentiometer as volume control. So your Eurorack level signal coming in will leave looking like a Eurorack audio signal. This just helps us attenuate over top of that. But in these Emily Gillette circuits, this one's not doing it. Some of them use a voltage reference. So we have a negative 10 voltage reference. And if you go through the transfer function with the biases in here, 180 to 100, 47K, basically what's happening is the MCP 6004, the operational amplifier that we're using here, is only being given 3.3 volts. So it can only output 3.3 volts. If you're only outputting 3.3 volts from 0 to 3.3 volts, right? You're only going from 0 to 3.3 volts. That's what the microcontroller understands. That's what can go into your analog input of the microcontroller. You don't go above that. You do not feed negative 10 volts to the microcontroller. You do not feed your Eurorack level signal directly to the microcontroller because the microcontroller goes, ah, and then it blows up and then it starts smelling funny. You don't want to do that. You blow up your microcontroller, it'll never work again. You're out $14 because for some reason somebody wanted to use a completely obsolete STM32 chip that nobody manufactures anymore. I'm angry about how expensive that chip was. But anyway, you've got a Eurorack signal, so we need to actually turn it into something that goes from 0 to 3.3 volts. So if you add that negative 10 volts to your waveform, your negative 10 to positive 10, you've now offset your voltage into the negatives. You've biased it down with that negative 10 volts. So now instead of your signal going from, I think it's like, it's 10 volts in total, so maybe the 5 is, I don't know. But so your voltage is now going from a really negative voltage to 0. And if you put that into an inverting op amp, it is now attenuated down to 3 volts, but it's the opposite of what it was. So now it's a positive voltage. So you're 0 to 3.3 volts. So the 47 kilo ohm, the 180 kilo ohm, and the 100 kilo ohm all work together with the negative 10 volt reference to bias your voltage, your negative 1.5. Wait a minute, that doesn't make any sense. Anyway, this is whatever. It biases it to the negatives, flips it, and attenuates it, right? So that if we're looking at R36, is that the right one? Wait, where are we? No, that's an input. Hold on, we're looking for whatever happens next. I just wanted to show you guys that negative 10 system. It's something that's unique to these. Well, it's not unique to overall synthesizer design. I don't know where it came from originally, but it's something interesting that I found in the Émilie Gillette designs for mutable instruments. Anyway, let's a little concentration here. So L in, that's L out. We want we want L in, because I think there's probably another stage to that. Okay, that's all those. What's on the other page? Let's find where we're going with this. I don't think LN is directly going to go into the analogs here, unless this chip can, the WM8731 can handle some crazy shit. L out, R out, L in and R in. Okay. Lilinian, R Lilinian. Pins 20 and 19, but those go up to like 10 volts. Let's look at the WM8731 datasheet. Oh, I feel like I get nothing done on stream. I get next to nothing done, but I'm explaining myself as I go. And so if even one person is better off from all of my machinations, they will be worth it. The hell, temperature range. Okay. Moisture sensitivity level. We don't need to worry about that. Pin configuration for the QFN. Electrical characteristics. Here we go. And recommended operating. So voltage 1.4 to 3.6. So we're a 3 volt chip. We can't operate in anything near Eurorack or Eurorack amplifier levels. Total input signal level 1 volt VRMS. AVDD over 3.3 volts. Signal noise, dynamic range, harmonic distortion. We don't need to worry about that. I'm just looking at what it can handle. So 1 volt going into the ADC from LN and RN. So I guess that circuit is supposed to be attenuating. Why was our voltage on the output so cooked? 53 and 5.6, 5.6. So we're half of that input level. And then we're getting rid of the DC component? Wait. C36. C13. Well, actually, we could just pick it up over here at this thing and see, because it seemed like it was a little bit hot. There's C36. So on the positive pin of C36, we should see our attenuated sine wave. Okay, that's at 2 volts. Whoa! Did we blow up the DAC? Is that what happened? All right, let's double check our component values, because that is hot. Oh, let me open that. You found it. You found it. The holy post. I need a keyboard to do this. Decided to break down step by step the hack and upgrade of oscilloscope. USB hub, keyboard, Wi-Fi dongle. Wait, but you need a dongle. I thought it had. Mine has Wi-Fi. My Wi-Fi. Hate. Android ADB, software to access oscilloscopes over the network. Utility for the hack. 2 ways to hack. Turn your oscilloscope into an older model, or into another model, or 2, generate options for it that expand its capability. In any case, oscilloscope must be connected to the network and accessible over the network from the computer. I can do that. Wi-Fi dongle must be connected to the oscilloscope before turning on the power, otherwise the oscilloscope won't see it. I already have Wi-Fi, I think, yeah. Don't worry too much about the other hardware. I see. Okay, wow, there's the whole thing. It's just everything I need to know. Sweet. Well, we'll have to do this at some point. I've already hacked this scope to have a big fan. I put what is it, an 80 millimeter fan, or was it 120? It's an 80 millimeter on the back. I've got a Noctua on the back because things need to be quiet in a studio, and so this equipment was too loud, too much of a drone. Okay, so I'm theorizing right now that we're completely cooked coming out of that amplifier over here. I don't know if that's necessarily the case. Maybe it's supposed to be like that. Oh, well, here's our first problem. Handy dandy to have scopes have this little switch on it that does ×1 or ×10. And so if you're in ×10, I don't know if that's done anything, but now I think we should have more accurate reporting. Well, the RMS is supposed to be 1 volt. I don't know why we're so DC offset here, or how that's acceptable coming out of a capacitor, but we are between 1 and 2 volts. But when I turn it up, that is huge. Clipping at 6 volts, that's not good. Wait, hold on. So my amplitude is a little bit big on the wave that I'm providing it with, I guess. If it's supposed to be -1.5 to 5, we're -5 to +5. So the component of it that is positive is probably from 2 volts down, maybe. Also, what's channel 2 settings? 2's probe is 1x. Okay. All right, so that's okay. Yeah, it's gone through 1 inverting operational amplifier, so it is supposed to be out of phase. And it's not out of phase, it's inverted. Get it right. So we've gone through the inverting amplifier here, and I guess the transfer function is 3 to 22. Let's check component values on this thing. I know it's purely semantics. Talking about a waveform and calling it, you know, is that 180 degrees out of phase or 90 degrees out of phase? You go, no, it's inverted. Is like, come on. You know what I was saying. All right, turn everything off and get the Canada arm. Actually, these are no longer Canadian. I bought a nice one. This is not necessarily nice, but it is like a color screen. It's a modern one. I have a black and white version of these, and when you power it up, it gives you the Canadian flag, the maple leaf. Okay, so in circuit is kind of a weird way to do this, but R57 and 47. R47 is supposed to be a 3.3K. 3.3K, it's 3.25. You can't see the numbers on that. $3.2K. Let's check its buddy over here. That's not right. There, that's right. 3.2K. And then this one is supposed to be 22, 21.9. $20.45. Yeah, it's close enough. I read the DH0914 does not need another daughter board to add the AFG hardware. It doesn't have. You don't need a daughter. You do not need. Oh, it does need. Oh, sorry. It does need another daughter board to add the AFG hardware it doesn't have by default and software locked. Someone published it on GitHub. What the f? So I could get a combo function generator out of this if I do this project. Leaving Twitch, dun dun dun. This one, bring this over. Auto wave generator, DHO 08-900. Artificial waveform generator. The one thing that I need to do also is to make the logic cable, because that's just LVDS. Dear God. I'm not sure if I have this hardware, but I might have some of the components. Holy. And so now you're able to arbitrarily waveform generate. Uses the same interface and the same DAC. Cheap production, including assembly, by minimizing the amount of extended components from JLPCB, minimizing distortion. Does anyone have one of these extras sitting around? Because I know you can't just order one PCB. That's cool. Yeah, that would be a testing solution for audio waveforms, huh? It's got a noise source. There's no need to change the resistors for version detection. 800 and 900. I mean, the DHO, really? Man. So you'd have to do some connector soldering, which is not hard to do. Crazy. So then I would, yeah, that's the alteration to the actual thing. And then I'd have, on the rear, I would actually have a an output for a function generator. That's cool. It's a lot of work. It's a lot of work. Hold on, I can cough. Okay. Yeah, okay, so it would be a whole thing, but it would really improve the versatility of my scope in terms of tuning these synthesizers if I had a waveform, an arbitrary function generator that would output something and then I could plug it into, yeah, that would be cool. Although having it all together with an actual power supply for Eurorack stuff is, that's, you know, this is good too, because this costs me pennies on the dollar. I guess, yeah, you can have it automatically go through, but there's actually a GitHub project. It's in the stream project section. I can run a Python 3 program that'll pull it through a bode plot using, I think it uses a square wave. I don't think it's using the function generator for that. Maybe it is. Maybe that's what it is. I was wondering how I was able to get a bode plot from just a square wave. Let's see if I can find that. No, I don't have it. Well, actually, yeah, I can pull it up from there. Hold on. Pull it up from the GitHub that I posted into my stream of projects about using my own my own stupid oscilloscope to be able to actually do stuff. But I found this first from an EV blog link. Nope, that's the wrong one. That's the wrong one. I'm looking for this. DHO remote from T-Band. And this will do your bode plotting so you can figure out where stability lies just with a little Python program. But maybe they say that you need do you need the function generator version? Request a bode plot from raw data, the oscilloscope. A network connection is needed. The bode plot shows the amplitude phase difference between channel 1 and channel 2. Channel 1 of the scope is connected to the input of your network. Channel 2 is connected to the output. You need to drive the input of your network with a square wave signal. The program takes the fast Fourier transfer of channel 1 and only uses frequency bins that contain sufficient energy to create the plot. Channel 1 should be driven by a signal that contains a lot of harmonics like a square wave or a pulse wave, but any input will do as long as the frequency, as long as there is frequency content. At the point you want to see, as long as there's frequency at the point you want to see. Damn. Since the harmonics typically lower or higher, 20 dB bode plot, made from a single capture, covers 3 decades in frequencies before the noise plays a role. A pre-capture option lets you capture multiple times. Each capture should be driven, blah, 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 blah. But yeah, this is apparently you can do bode plots without the built-in function generator. It will just do a slightly more limited, probably, bode plot, but yeah, loop gain analysis and stuff like that. Pretty crazy. I don't know if I really need to go to the point of doing bode plots. It would be nice to characterize the powered multi, but that's getting into the weeds a little bit. Anyway, what are we doing? I gotta stop getting distracted. We've solved the scope thing. I've got that open in a window elsewhere. Maybe I will go down the epic path of possibly bricking my own scope by upgrading it, but we'll see. If I add everything as accessory features, then I probably won't brick my scope. But no, we're looking to get bricked up about this signal here. We're looking for what is happening with our waveform. How is it able to get all the way to the WM28 blah 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 acceptably in this scheme? I don't know. We're taking it on the output of the op amp, which can get pretty cooked, and then we're putting it through a voltage divider and then like a capacitor network thing. I don't know what's going on here. This would put it out of phase a little bit, and then this would kill any DC component, but then we see it with this massive DC offset. So I don't know what's going on. What's up, Rila? Whatever. Something. Why are there 3 Ks in there? It's a teddy bear PFP. Okay. The software hack from 125 to 250 is pretty straightforward, especially if you only generate the license keys and unlock it via SCPI, since you don't actually modify the firmware directly. I see. I hope you get electrocuted. Thanks, I appreciate that very much. As a name with 3 Ks. Okay, so RIN is coming from all of this crap that I don't really know what's going on. If we look at R53, what do we get? We're probably going to get the same wave. Where's my waveform? Oh, I turned it off. So let's turn everybody back on now that we know that our components are the right values. And so everything that's happening in here is supposed to happen, I suppose. Things are supposed to happen. See, that doesn't change. I guess that's just our input coming back in for feedback. I don't know why I don't see a difference. I guess we have to see it on the outset of this thing. And this one's outputs are, they're like here. And this is our attenuated signal on the output of the potentiometer. That is somehow getting way up above. Where are we? What are? Holy crap. So that's like a full bandwidth 12 volts. So I guess we literally are just attenuating. This is just attenuating our input signal. So that's full input signal coming into the device. We still, again, the microcontroller is not telling us that there's any kind of a waveform here. This should be like a Christmas tree up here. These LEDs should be all lit up. And we know the LEDs work with the microcontroller because it does a startup sequence. So we're going on to the next piece of the equation, which is, hold on. I want to do a full dump of the SD card, since as far as I know, the firmware is on the SD card and can die pretty easily while you're connecting it with ADB. Huh. That's a lot of work, but yeah, should probably do that. So I guess the next step is going directly into the WM2812. But what? Wait, but that's like full bandwidth Eurorack level signals going into this chip that said it only has 1 volt. Why is this not dead? Maybe it is dead. Well, let's check to see. Is our microcontroller is going to be talking to pins 3, 4, and 5. So all the way up here. Pin 1, 2, and then we got pin 3, and that should be like crazy digital nonsense. Crazy digital nonsense. We got nothing. There's like, what is that, pin 6? 1, 2, 3, 4, 5, pin 6. Nothing. The codec is WM, I believe. Hold on. I2S in is pin 6, ADC DAT. That's doing something. That's not doing something. That's doing something. Pin 3, I2S clock. So it's using the I2C version of sound, I2S. And we got 125 megahertz scope. Look at that waveform. Yeah! You see, like, I don't even need 125. Oops, I slipped. Whoa! Look at the ones and zeros. Sigma delta, hold on. Just look at the data sheet. Yoink, yoink. All the way up. Low power stereo codecs with an integrated headphone driver. It's a portable internet audio codec. Internet audio? Wait, why is it internet audio? Where's the internet come to play here? I don't think we're swapping IP addresses. But it's got a headphone driver and a programmable sample rate. So Emily Gillette chose this, and it's probably a pretty good piece of hardware, but it's not super rare and it's not audiophile. This is just fine for Eurorack. Just fine for Eurorack. I'm just wondering, on the input, why, I mean, so the analog input, it's like 0.3 dBV, input signal level at 0 dB, 1 VRMS. What's the max? See, I'm not like great with audio engineering. I don't think in decibels and stuff like that. I'm not good at that stuff. Microphone bias, 100 millivolts. 80 dB for mute. Mic path gain boost, 14 dB. I just want to know what my max ratings are. I don't believe I'm blowing up the codec, but I don't know why the codec, it appears to me, looking at how this thing is not working, the codec isn't communicating with the microcontroller, and the codec could be broken. We know the microcontroller works because the LEDs do their little dance when we turn it on. I'm better with RF engineering. I know my way around RF engineering. I kind of tootled with the, I guess he used to own a company. It was like an RF company in Maryland that did a lot of like satellite stuff, but he taught me a lot of really cool stuff with RF, and I've always been a little comfortable with it, but it's a weird thing to do. Probably lost a lot of that knowledge, to be honest. I'm sitting here doing just basic audio electronics, you know? I don't know, man. I guess we're not blowing it up, but it just seems weird that we're sending full Eurorack voltage on the outset of our volume control directly in, and let's take a look at that here. Let's get a little further out here on the scope so that we see that it is indeed a waveform, and our thing is set to plus minus 15 volts on this chip. LLINEIN, LLINEIN, left LNEN. What the fuck? Pin 19 and 20. 1, 2, 3. These look a little crusty. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's pH out. We're okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I should have known. 14, 15, 16, 17, 18, 19, and 20. So it's these two right here, which makes sense because their capacitors are like right here. I just lost the pins. 15, 16, 17, 18. Okay, these two right here. Oh, it's just clipping immediately. That's at full volume, and if I turn it down, there it is. Between 4 and 5 volts. Actually, no, 5 volts and ground. I guess is that okay with the codec? I guess. What about the other channel? If I gotta plug it in, but if our audio signal gets all the way to here, then it's something with the codec chip not functioning, and those digital inputs are looking kind of crusty to me. And I might want to change out that one resistor because the two channels are a little bit different from one another, and I kind of want them to be the same. So there's our waveform. That's it clipping. It's overdriven. Although our waveform is a lot. I don't think you shouldn't be able to kill your hardware with a waveform. That would be really bad if Clouds is able to blow up with a outside waveform. Over to the other channel. Oh, damn it. Which one was it? It was this one. Okay, so I was wrong. The audio input is fine. We're getting all the way to the DAC. So there's something wrong with the DAC. So we are now in the realm of digital signals. We're no longer doing the analog stuff. So what is not happening with the WM8371S? This sucks because I don't really like this chip. I didn't want to deal with this. Okay, so let's check. It's not, well, it's not, I guess it's not full 12 volts. It's whatever this is. It's up to 5, 0 to 5 volts. It has been attenuated. So we're 0 to 5 volts in this 3.3 volt device. So I mean, really technically, like, it should be like that. But instead, if I cook this, it cuts off at 0 to 5. Which, hopefully that's enough protection that I don't blow it up. I think I have one more of these, so I could swap this out. It would be a feat of hot air to get it in, but so far, I mean, we've seen the signal going into the chip itself. I am not seeing satisfactory data on the I2S S clock and the I2S R, which one it is? I2S is SYN. It's SYN. Okay, LR clock and then out. We're looking for the input, unless in is out. DAC, DAT, digital to analog, analog to digital. So we're on pin 6 and 7. I know, these are like $15 chips, all of them. Because these are old designs. By old, I mean like 2015. Can you believe that we can call that old? And so the chips are like, due to the chip shortage and COVID and just technology moving on, they're hard to find. And so they're kind of expensive. And so it's a specific DAC that we need for this thing. So if this is messed up, we are not having a good time. Don't tell me that. Don't tell me that. Don't tell me that. Don't tell me that. Don't stop talking. You're banned. Pin 6 is our buddy. 1, 2, 3, 4, 5, 6. I need high voltage probes, the real pointy ones that I use on my multimeter. We got nothing. Pin 6, ADC DAT. Pin 7 is the left-right clock, so we should be seeing a waveform on that. That looks like a left-right clock. Pin 7, nada. Sorry. What? Wrong pins. 1, 2, 3, 4, 5, 6, and 7. You can't have consecutive numbers as your super cool I'm in on the joke number. It's like bad. Pin 6 is ADC data for the inputs, and we are giving it a juicy sine wave, and it's not doing anything. Let's check up at the chip. 1, 2, 3, 4, 5, 6. The left-right clock is working, but the data is not coming out. What about S clock and digital in on the main chip? Maybe they're not using I2S. Maybe they're just not using that, even though the left-right clock is still getting data. Pins 23 and 24. 15, 15 is 30. 30, 29, 28. I gotta get lower down there. These jacks being in the way. This is done, by the way, on this side of the board so that quote-unquote musicians don't run into all of this hardware and like knock it off of the PCB. Don't short the chip pins with your probe. I'm always careful about that. 30, 29, 28. What are we looking for? 24 and 23. 30, 29, 28, 27, 26, 5, 24, and 23 are these two right here. This is I2C. And it is dead. Let's see if the bot... Wait, those are the pins where our audio is coming in. Our audio is 12 and 13. Am I counting this wrong? 15? 1, 2, 3. Wait, hold on. I've got a pin out over here. I don't need to be doing this. It's got the whole data sheet. I have the whole data sheet. Why am I sitting here going 1, 2, 3? Where's the... There it is. Low line in, R line in. Oh, we're down here. Okay, I see. V, did you call me mid? I haven't tried the McBias yet. How is the McBias? It's pretty good. R out, L out, HP ground, RH pout. ADC data. B clock, clock out. Wait, where's our S clock and SD in? 23, 24. So it's 14 pin. I counted that wrong. Stupid. Okay, 14 pins. The ADC full scale input is 1.0 volt RMS at AVDD 3.3 volts. Any voltage greater than full scale will possibly overload the ADC and cause distortion. Okay, so that's they're fully embracing distortion. I was looking for like the when do I damage the chip voltage? D ground, DCVDD, XTO, XT1. So those two are the crystal pins. And then below the two crystal pins. So ground, ground, crystal, crystal. And then these are the I2C, these two right here. Cool. Love that. Okay, so they're both just kind of sitting. Okay, so back over to our schematic here. And we've got R40 and R41. R40 and R41. That person still wants me to electrocute myself. I don't know how I would manage that. 44, that's C44. Oh, 40. Where's 41? 32 footsteps counted on the road. 32 footsteps. The road into the sky. That would be the pull-up side, which should be at 3.3. So it's, yeah, a little bit below 5. Actually, wait, we've got voltage levels on this. Voltage, C2, yeah, 3.3. It's like 3.1. I watched that long video about all the features of this scope, and I'm still just using it to probe around voltages. So this is just hanging out at 3.2 volts. So we don't really have I2C. Is the micro attempting to communicate with I2C using I2C? What is 41? It's 41 and 40. Oh, okay. So these are my SDL and SCAs, and I'm guessing that this side of it is the one. Actually, we could just put still. We can see which one is which. Let's just take a look at it here. I forgot that we have all this. You kind of forget that you've got all the sources you could ever need. When you spend 10 years reverse engineering IEDs, you kind of go from like what's on the board. You don't trust this stuff. Yeah, okay. So which one goes to our DAC? So it goes down and under and goes to the DAC that way. And so the top pin is the one that should have some kind of a clock signal on it, just something, anything. So we should be seeing, up here, we should be seeing a square wave. But we just see nothing. Nothing. Now what if we zoom way the heck in? Nothing. Okay, so that we would probably have seen like a little shading below the line if there was in fact a digital signal there. So SDA and SCL are not doing any types of communication. Now let's try turning it off and turning it on again and see if we get anything on the line here. R40 is clock, so let's go from the data line so we get something a little bit more dynamic, and we'll see if it's doing anything. Voltage range for analog inputs is A ground minus 0.3, A VDD plus 0.3. Which pin is A VDD? A VDD is 3 volts. Well, what if they didn't do that here? No, it's 3.3. It's 3.3. It's on the other side of this 100.1 F cap. That's this AVDD. So plus minus that by 0.3, which is a little bit, I mean, I think it's probably distorting. That would be distorting. Okay, anyway, not important details. The important is that we're looking here, and let's see if there's an initial burst of communications when we turn the system on. No, nothing. 5 volts seems a bit high with 3.6 volt max. Well, that's why we're able to attenuate it. That's why we have a big range on the attenuation to go way into distortion or way into super quietness. That's built into the system. I assume that it's not going to blow it up. But all right, where's our I2C coming from on the chip? And are we using I2C or are we using I2S? These are the I2S pins. Oops, sorry, you guys can't see. Let's here, can we pull everything up on this? What else do I have here? Frame, spring arm. Okay, so if I pull this in, I don't think I've framed PC. Hold on, let me just look at my scenes here. Blood glucose, face, spring arm, thermals, chat, and burn the subs. Yeah, so I'd have to do some monkeying around with whatever it is with OBS in order to get that working. That ARM chip I have soldered several times, and I'm pretty sure that it is in fact connected, but we need to take these lower pins and see that they're all doing what they should be doing in terms of sending data to an I2C device. So good, good, not good. Well, there is no data on that one. What if I unplug? Let's check the pin itself. Okay, so data, data, no data. Unplug the plug, and plug the plug in the plug. Nothing, okay. And those, I believe, hold on, I gotta zoom in over here. I2S out, I2S in. I2S in has nothing on it. And the pin is connected? Well, we can't really know. And then skip 2 pins. SDA, SCL. Let's try that again. Data, data, should be data, should be data. Skip, why is there data? Skip. This one and this one should be our communication data. Why was there stuff on the... Oh no, those go under the board. Ah, wait a minute. Wait a minute. No. I got my layers mixed up. So yeah, those are the 2 skip pins, and then these do nothing either. We are over here now, and we're next to C24. Oh God, you guys can't see that. Oh God, you guys can see that. What's that? I don't know, vacuum tube thing with pin count. Oh yeah, I got that one. That chat goes into the main chat. And then the scope is in the way, so let's move this up so at least you guys can see kind of what I'm looking at here. I guess I can collapse this too. Or we'll just drag the window over like that. Super professional. Okay, sorry, you guys couldn't see what I was staring at. I'm looking at the board layout right now to figure out where these pins are because they are all labeled. I've got labels directly on the pins, very nice. Should C19 and that pin from the NCU be bridged? Yeah, because all the stuff came off of it. So C24, and then the pin's right next to it, and it's going to be these 2. Yeah, it's something that I had to like check over directly because it was happening. And I was like, that's really bad, but it's just the limitations of the printing of the board. I gotta get in there. Hold on. This is the same problem I had with the hot air setup, is that you can't really get in there because there's all this stuff around the chip. So, and then that is I2C, and that is I2C, and we're seeing the same thing. What if we come up here? So it's not a connection issue, it's just an issue. Bless you. Okay, so I2C is running I2S, which is I2C sound, is running its clocks to both of these, this here and this here, for its input and its output clocks. I2C is doing nothing. The chip is booting up, and it's going through its boot sequence. We know that because the LEDs do their little dance. So when I turn it off, turn it on, doot, 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 doot. See that? Nice little sequence there. And it's using the bicolor LEDs forwards and backwards. Oh no, these are 3 pins, never mind. But it's still, it's going through a sequence with different colors. So it's coordinating which LEDs are doing what using this chip here, this 74HC, I think it's shift register. So that means the microcontroller is doing stuff, right? It means the microcontroller is able to set highs and lows on those pins and affect control over them. So why then would it not be sending anything out? If I go to different modes, maybe, by clicking it, you can see that LED started flashing. Different types of clouds. Oh, I think I'm saving. Yeah, this is the different modes. It's like, I don't know, man. Everything's working, but nothing's working. How do I get you to output things? And we know that our audio signal is getting all the way into the codec chip. So is this dead? It might be that this is dead, or maybe there's a bridge on the solder somewhere. Let's get real close in. Let's get real close in and inspect some of that soldering. This stuff will fool you because it looks like it's normal sized electronics, but this stuff is actually really, really, really small. Really super small. I should be characterizing filters today, but I kind of wussed out on it. Oh, gotta be careful with the cable. If I touch the cable wrong, it will disconnect the camera. When the camera disconnects, it means I gotta reboot a bunch of stuff. 0201 sounds like torture. I mean, those two look kind of bridged, but that might be flux. Yeah, let's get the real needly tipped iron. This should be achievable by drag soldering with a big tip, but oh, hold on, we gotta wait. I know what I'm doing with soldering. Just trust. It's okay. I have a plan. Well, we gotta wait. We gotta wait for the ad break. So I'm just waiting for the ad break. Taking value from my paid customers here. 6 days ago. I was really streaming. It was 6 days between streams. I'm sorry about that, everybody. I'm going to try to get more streams in. We have a lot of stuff to do. I've got too much to do, and my ThonkyCon connectors are here today, so we'll be able to finish building these modules, and then I need to figure out like a test procedure that'll work in audio, where we can tweak the knobs and take a look at the difference in sort of the results of frequency filtering from the nonlinear circuits filters, and you know, make sure we know what we're doing. It seems like every time I build a module, I have to do a deep dive. You're back, but not everybody is back. I've got stuff that'll tell me when the ad break is over. Particularly this little guy right here. This is for raids. This means that a channel is raiding into my channel. I have another one of these that I'm going to build up so that I can put these on the wall. These are things I haven't been able to get to yet because of things like this. Soldering this was actually a nightmare. But anyway, these are going to go up on the wall, but this will also tell me when the ad break is over. When that thing activates about 8 seconds after, the corresponding siren is in parts. It is back in the back of the shop. There's a proper motor-driven siren that uses sort of drone motors. It really shouldn't use drone motors because originally those sirens were built from just like bench grinders. And you can tell because they're using your basic universal motor with an output on either side. And it's literally like your normal bench grinder, but then they put this like air pumping structure on the outside. It's just a big thing with slats. And so somebody on Thingiverse made that. I printed it. It's sitting right there. It's actually, no, it's actually to the out just off camera. And I've got the motor controllers and everything. So I'm going to be running one of those. Well, no, the original version, the 1940s version of the siren would use just AC and it wouldn't be a brushed motor. But the ones that I have use BLDC motors, the brushless outrunner or whatever you want to call them, linear, whatever, 3-phase motors. I've got a couple of those motors and everything. It's like really close to fruition. There will be a little siren that comes on. I have 2 dogs here right now. I have 2 corgis upstairs, and I don't feel good scaring them, so I don't know if the siren is going to be like full volume. And there we go. So I put a little delay on that, so that means that we're back from the ad break, and we can work on the soldering that I wanted to do. We were just talking about the air raid siren and some other stuff that's going on around here. The soldering looks bad, and I should feel bad for the soldering looking bad, but sometimes the soldering can look like this and be okay. Because it's loaded up with flux, we can't really tell if certain pins are shorting to certain pins. And I don't know if this thing cooked or what. So what I'm going to do is I'm going to come in with an actual really small iron tip. This should be drag solderable. You should be able to put this in position and then just go across these pins and they'll look really good. But in the troubleshooting that I've done on this board, it seems like we've kind of frayed some of these pins. It might be frugal at this point to just pull the chip and make sure that everybody's okay. But I did just get some new soldering iron tips in the mail, so I kind of want to use them. Actually, no, we're not gonna. We're gonna use the real pointy one. Pointy, pointy, pointy. I can't do hot air because it's got all these connectors around it. I'd have to build an air dam around the whole chip, which I've done before. We've been here before. This clouds has been sort of a thorn in my side for quite some time. Oh, there we go. I had to remind the soldering iron that it should wake up. Part of the annoyance of clouds is that clouds is built to be built professionally, right? The hot air station that I have is a Quick 816DW. It's the same thing that Louis Rossmann uses. I do not, however, use the volume of flux that Louis Rossmann uses. When you are hot air soldering, though, it is necessary to use a lot. There's a lot of leftover flux here, though, so we're doing okay. All right, so I'm just going down pin for pin and reflowing them to make sure. And keep in mind, everybody, this is very small. This is incredibly, annoyingly small. I don't have a lot of control. What is that, junk, or is that supposed to have a trace between it? That would be not supposed to have a trace between. None of these are. Oh, yes, they are, because they're 2 grounds. You can see that there's a little, what's called an air wire. That little air wire right there is supposed to be a ground plane, but then these have thermal relief on them. So with the ground plane and the thermal relief, you'll have a little tiny trace that goes between these 2 pins. So that's what we're looking at. Lewis uses the appropriate amount for somebody who is like putting a new chip into a socket. Like that, it's not the proper amount for a lot of the stuff we do. Now, are those the right pins? Those are 21 and 22, I guess so. It would be 28, 7, 6, 5, 4, 3, and 2. It's 2 and 1. Wait, what's the, oh, hold on. 14 and 14 is 28, 27, 26, 25, 24, 23, 22. Well, 23 is I2C SDA. Wait a second, this might be it. That right there. It feels rubbery though. Huh. Pin tool, pin tool, pin tool. Now, flux is weird and gummy and it causes cancer and it's all kinds of horrible shit. I'm good without using it. Plus, this isn't really moving with solder. I don't know what this is. All right, the schmoo's been clearanced. Let's make sure that none of the other ones are schmooed up too. Well, I have no choice but to destroy the silk screen in a little way, and that's not going to affect these two pins. So if there's no silk screen there, it's fine. There should not be anything there, and there seems to have been something gummy in between them. It didn't feel like metal, but it might have been. These two are not supposed to be connected, and having a ground connected to that pin is kind of in line with what we were seeing on the scope. So I'm really digging at that, but that's fine. I don't think it was conductive. All right, so let me just clean the rest of these up. I'm just going to go over them with this to just kind of clean it up because they're kind of weird looking. Oh, maybe that's just how they sit. Like it could have been like a burnt piece of flux or something like that. Dog hair. Who knows? Most of this is that I feel like I've already been here. I think we've already done this multiple times. Let's see if we can get these to be a little cleaner. And it might be that I just need to dump flux on them in order to get them to cooperate. That looks like it could almost be offset to a short. No, I guess it's okay. I can see a little bit of the PCB between it. It should be okay. I shouldn't need solder wick on these. Just let them flow a little bit. See, it's so much better looking. Make sure nobody's shorted. Make sure I'm not melting a Donkey Kong. I've got my, so you guys can't see my hand cam right now, or you can't see my hands on cam. I've got my other hand bracing this with a single finger. So this is just providing me with a little bit more stability and sort of confidence in my motion. It allows me to move in smaller increments because I've got this thing basically on a tripod now. You can see that part of it. I guess you can't totally see the iron, but a little bit. A little bit helps. All right, so, oops, slipped, went to the wrong pin, blew up hundreds of dollars of equipment. Okay, and then I'm gonna give it just a little or not exacto, scalpel, just a little nudge in between the pins. I think that's just flux there, and I shouldn't probably worry about it, but just in case. I may squirt this little goof off and see if I can't make it look a little better, because I think that's just burnt flux. But it's weird that the microcontroller isn't even like attempting to communicate with the DAC. I mean, I guess it could be that the pins are like just done with my bullshit. I think, are we severed on this one? Yeah. Oh, I need a. By the way, that dullness right there. Oh, look, it's so dull. We can't even see it really on the other camera. It's so small. Yeah, okay. So let's clean up a bit of the flux around this chip just so that we can see that everybody is properly connected. And I think maybe we might have cleared out a short. That might have been what was going on. It kind of is in line with what we were seeing from the operation of the chip, is that perhaps it is possible that I knocked out the I2C by having that short between pins. I need a blade. This on the bottom. Yoink. Can't get to it. There. You can buy these by the bushel. I use the 10A scalpel blade, and they're so much safer than your typical X-Acto knife. X-Acto knives like loosen up. These don't, for complicated cuts and stuff. I do want to do an FPGA module for the Eurorack that just is basically is just a filter, but it's that special FPGA filter where you take I2S in one end and then you've got 4 poles and just do a potentiometer for each pole. I don't know what you'd be able to do with that though. I have a tiny FPGA, that's the brand, and I don't know what to do with it. And I forget how to do FPGAs. A lot of the time it's just drag and drop, but so you're gonna see blood on my channel. It's doing this. Where's the handle? Okay, there we go. So I think this stuff is just shmoo. What's this? What if 2 digital signals short against each other? Has it been your experience that it will not damage the IC? No, that wouldn't damage the IC. 2 digital signals, as long as they're, well, if they're mixing with each other and somehow doubling each other, that would be kind of bad. But I think usually things are kind of limited in their voltages, and so they would just be kind of confusing each other. You're not really going to get like a double. I think that's just flux, y'all. I think that's just flux in between these. Doing a little mechanical scraping to see if I see anything shiny, but we already flowed these over. It's just these little, see those little things right there? That was flux. And so I'm just kind of breaking away those little bridges of flux. Flux should not conduct. Nothing there, nothing there. Looking good. All right, let's get a little goof off on this thing so we can get it clean. By the way, I'm not pressing down with this. I'm just very lightly moving it over the surface sideways to scrape away the shmoo. Why is that so persistent? Am I not seeing what I think I'm seeing? Oh, cool. I can use it as a mirror. Huh. That'll be cool for when I beat the bad guy, like the final bad guy of the circuit. Like, you can't even see me. And I'm like, oh, yeah. And I shoot him behind my back because I'm using my knife as a mirror. Yeah, that'll be super cool. Like, oh, bother, you're the best. I'm like, I know. I know I'm the best. Okay, shouldn't have to do that on a circuit. I'm just doing it because we're having troubles with this one. Let me get some Q-tips and we're gonna clean off all that flux. I need to keep Q-tips closer. I had a viewer that sent in foam Q-tips, and they were foam with a plastic handle. It was the least renewable Q-tip I've ever seen. It wasn't. It was a cleaning bobble device. Q-tip is brand. Okay, so I use Goof Off. Generally, it doesn't really hurt anything. You shouldn't leave Goof Off on anything because it'll melt plastic away. But in the time frame that we use it, it's not going to do anything. And I just dribble a little bit of this stuff on there. It's orange flavored acetone. The flux has no choice but to vacate the premises. And we'll watch it in action here. A little bit of that. And a little mechanical stuff going on here. That'll brighten everybody up. Hopefully absorb some of that flux. I can't quite get in to all of this here. And we can inspect and see whether anything is going awry. Like new. Let's see, we've got a little bit of parallax going on here where our camera is just slightly off axis with the hardware. So I got to tilt it by lifting my huge heavy pad to sort of do an in-between pins inspection. See, the solder mask is like a little bit done with us. Okay, what's going on down there? Look at that one. That one looks connected. That L out and R out. Hello. That's not supposed to be connected. Okay, so let's get at that with the iron. See if we can't. What are the, wait, the ones above it are, no, that's a ground, and then that's L out. So we got a ground and an L out sitting right there, and they look like there's something going on between them. Because there's something between us anyway. Oh. Nope, it was just shmoo. It was just shmoo. The iron immediately separated it, although if it was connected, that could have been related to our problems. It's really nice when you're troubleshooting something like this, when you find the connection, the problem, and you solve the connection, the problem, but oftentimes you are not faced with the problem. You have all kinds of other weird stuff going on. It's really hard to get that sudden aha, eureka, this is my problem all along. You don't get that very often. Now these two do look connected, and they do look connected by solder, but it might just be the lighting. A buddy of mine used a no clean flux on his robot, and I don't know if I like the stuff because it left behind flux. It sure was no clean, but man, you should have cleaned it because it's gross. I'm sure it functions just fine with the no clean flux. Yeah, it's nice when you're able to get that, but they're very hard to find, those aha moments. My problem is the aha moment is about 1 second. I don't have to have a final boss fight with this stuff because you go, oh, it's that, and then you correct it, and then the problem's gone. And then nobody gets to see you like have an epic battle with the final boss. You don't get that catharsis in your content. Oh, okay, so that's me. That's exposed circuit board. That's FR4 right there. Okay, so I've done all I can. I do not think any of these are actually connected. There's just a little bit of shmoo between some of them. And some of them have been harassed to the point where the FR4 is actually exposed. So unless the IC's dead, this should be its best representation. If I turn this back on, we do our little LED dance, which is actually really quite nice. It's a cool little sequence of LEDs doing their thing. And then we've got audio going into the channel, but I have a feeling we're going to not have as many active. And if we check I2C, which is these, I2C is which two? These guys. Yeah, nothing. It's 222, 2K. Guys, I do not know. I think this is what stumped me about clouds before. Those are not used for anything. Those are our LR clock. So LR clock still works, but our I2C is just a flat line. All right, double check the resistors. Maybe we're pulling it up too hard. .222 is 2.2 with 2 2s, which makes it 600 ohms. Wait a minute. Wait just a minute. Well, testing these in circuit is another problem. 844 ohms? That is a little sus. Let me flip the probes, try it the other way. Same number, 6.3. 1.9 ohm, what the hell? 845 ohms instead of 2.2K? Seems maybe those 222s. So, but the I2S stuff that's not communicating doesn't use that. But then again, if the microcontroller is trying to pull down that signal level and it's got like a 200 ohm resistor there, it's not going to be able to do it. But if it wasn't able to do it, we would see it trying, and we didn't even see it trying. There's probably a lot parallel with them, but not on that I2C line. Talking about these two that go up and then down to there, and then they go over and under to the WM8731, and we're testing these two right here, which are supposed to be 2.2K. I'll wager that if I unsolder one of those, it'll still. It's a weird, yeah, that's a weird amount of ohms. Did we partially blow up our STM32? Because the STM32F405 is doing fine. It seems to be working fine. It called its mother the other day. It's just well adjusted. It's doing good. It's having a great time. This is off. This is off. Yeah, like there's nothing in between the pins up here. That color scheme, oh God, I hate it. I can't inspect this for crap because I can't see any differentiation between this stuff. It's doing good. It's doing fine. I'm wondering if maybe I blew up part of a microcontroller and somehow it's soldiering on without us. That's really all I can come up with. What else could it be? Yeah, see, those aren't contacting. We've got the 222s. What is... No, that's not... The 222 would not be a code with a different resistor. I mean, I can get the fancy soldering tweezers from Pace, but they're like $1,000, and in every single electronics lab that I've worked in, the soldering tweezers are collecting dust. Nobody uses it. It's a single tasker. It's not worth it. It's like the number one lusted after. Wait, why are C28 this type of capacitor? Father, what did you do here? I think this is a 1-UF, but use them for rework and a rework and an internship. I see. Yeah, I don't know. They're not worth it. They're just not worth it. They're too expensive. I wonder, there's probably a cheaper version of it. I think that's a 1UF. Maybe the 1UF is not doing its job as that type of capacitor. I don't think I have that capacitor though. Let's check. One off, but that's 50 volts. I wonder if that's going to be... no, that's way too big. I think that's the larger... Tweezers. Tweezers? There you go. Scalpel. You concur? That ain't doing it. You ain't it, man. You're too big. Too big. I need the 25 volts or the like 10 volt, 5 volt version of that. I don't have anything like that. Yeah, well, specifically for that one task, but then, you know, what do you do with them out when you're done? Like, soldering iron, I can jump to other tasks quicker. I'm gonna wager that it's the codec that's dead, but we don't see specific evidence of that other than not getting an I2C signal, which is a weird thing. What else? I mean, what else? How do I make clouds do stuff? In-gain, density, texture, blend, freeze, trigger, position, size, volt per octave, blend, out, right, and left. So I think possibly from the get-go, this thing should be sending out stuff. I'm having a conversation with 42 other people. Please. Don't just say, I don't know in the chat. Yeah, specifically like the I2C stuff on the microcontroller. I've never seen a microcontroller break like that, though. How's it doing LEDs? How's it doing the LEDs? Oh my god, this is just a chunk. Look at that. Software load, software mode, LED enable, LED clock, LED data. Man, there's a lot of pins on this thing. I don't know where the hell pin 57 would be, but we know that it's sending like a specific shift register thing all the way over to the LEDs. Other than that, size pot, pitch pot, all that stuff goes in to the microcontroller. All the potentiometer inputs into these analogs, and then who knows what the software looks like. I don't know if the Emily Gillette software was open sourced. I know people do know the software, and you can get it all over the place. I think it's on the GitHub, but I don't know about the original code. Man, I don't know. If we pull this, I wonder if we pull the WM8731, which I may or may not have already replaced. We pull that off with hot air. Will we see an attempt at communication on those lines? I do kind of want to pull the resistors, but at the same time, 222 is pretty definitive, and we've got other data lines, the ones for input over here, that are not working. They're not showing any data. So could it be that this whole thing was nerfed and I'm unaware of it? Do I have another one? Let me check my stocks here. You know, you usually buy one spare when you buy stuff like this, and I think I have one spare, but some of these old codec chips and stuff they're not around, and so they're really expensive to try to obtain. You know, the more I work on this right now, the more I realize that we probably already did this stream. I probably already did exactly this stream, but I put clouds all the way back together and did the front panel for it, and I was like, why in the world would, you know, why doesn't it work? I'm just going to pull it apart again and I'll fix it. It's probably something silly like a solder bridge. But I think we did this exact thing. Do you have any kind of inventory management system, or will you just look in your drawers? I'm just going to look at my drawers. Why does everybody want to overcomplicate something with a GitHub project that some asshole is not going to maintain in 5 years? I have had my parts storage for the entirety of my existence, and they're just disorganized. It's fine. Nope, none of these are what I'm looking for. Oops, turn that off. Blink. It is very weird that I2C came up with a very, very low resistance value. And it would stand to reason that it's not communicating with the other stuff because that line is being held high too strongly through a small resistor. It would have, you want like a big resistor, that way it's easy for it to pull down and communicate. Diodes and stuff. That might be in some of these, but there's too many components in a lot of these. That's not a big chip. That's small chip, nothing. Nothing. Okay. You are not codecs. We're looking for big wide surface mount. I might do that, but it's a pain in the butt. Okay, these are all op amps. I think it's in a labeled bin because I built clouds a while ago. And it might be unlabeled. WM8731, ADC DAC. Hello? Holy crap, I got like 12 of these things. Oh, the chip's going, it's gone. How do I have why did I buy so many of these? Maybe they were cheap. They must have been if I got this many of them. Holy. Yeah, you're out of there, bud. We're replacing you with this one. So at the very least, I'm going to replace that, but let's take a look at the resistors first. Good to know. Well, thank you, Emily Gillette, for using a cheap DAC that I have 45 of. I wonder if those came from a different... Hold on, let's check the price. They might have come from a different thing. It might be just that another product that I've worked on uses this... I'm human. Stop it. Okay. WM8731. Yoink. I hate how it comes in light mode first. The whole purpose of dark mode is not to flashbang us. 0 in stock. Huh. Seems I may have gotten these from a different effort. I just happen to have it? No, that might not be the case. WM8731. How do I have so many then? I must have gotten them before they became $15 each. That's the data sheet. I would like to see the Mauser page, but this is shopping. $23? Woof. We gotta make some designs with the 8731s on them. 15 on the LSCS? Damn. Yeah, I don't know if I found a bin of them somewhere or if I bought them in 2016, 15, 14, 13, 12. I don't know how I got my hands on so many. They're out of print. I see. Well, I must have gotten them when they were in print because I've got a bin full of them. And I'm not a millionaire. If I could get away with selling them for $15 a piece, I probably would. Nobody would buy them for that price, but... Hold on, I'm putting my bins back together. There we go. Okay. Everybody in the drawer. There we go. Oh, I see. It's been years. Are you sure you aren't a billionaire? I know, seriously. That would be good to know. Maybe I could tell myself if I was. I would be very interested to know. But apparently I've got these things just coming out of my ears. I gotta like make a module that uses them. Okay, so these resistors could not be in a worse place, but I'm gonna do just the bounce from pin to pin in order to move one of them out of position so I can get the tweezers on it out of the circuit. I see there are clones. How are your clones? Please, please move. Please move. Please move. Please, please move. Please move. Please move. Please. It should be a lot easier to do this in this size, but I guess I'm just not getting it. Quit heat sinking. Come on, bud. You can do it. All right, I'm gonna add a little solder just to give it that thermal sink. I've also got this wire sitting in front of the iron that will melt the second I touch it. You wear a big hat. You wear a big hat. Everybody's wearing a big hat. Come on. There you go. No, 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 no. Oh, you bastard. It like immediately met up with its buddy. Finally, I'm free. Don't you dare. What are you doing? I'm gonna throw this thing across the room and we're gonna put new 2.2 Ks on here. I'm gonna throw it. I'm gonna throw it. Let go of the pad, you little, it's gonna solder itself back in. Good enough for me. That's good enough for me. That's isolated enough. Now I can test it. .195 K ohms. 2.1, yeah, so those are fine. The values of those are fine. Let's get that one back in. Maybe the codec is blow-decked. All I can come up with. And if it's fine, I got plenty more. I shouldn't have plenty more, but somehow I do. I think the the co-op job that I had at Drexel, I think they may have used them at that place in Westchester. I wonder if they're still around. I don't think people are using that technology anymore, but it was pretty novel for the time, and it was audio stuff that was right in my backyard, and I really should have I should have kept up with those contacts. I could have still been working in the audio stuff. These are guys from Creative Labs. From when it got bought up from China, they went over and made their own company that was using some concept that they were working on bringing to Creative Labs but didn't. And they made a company out of it, which is pretty cool. To be able to do like weird electronics like this and rub elbows with music professionals that's pretty cool. That's a cool job. They look connected. I think that looks connected enough. With the DIY solder pads, I usually like to have a little like bobble on the end. It's inevitable that you get the bobble. You don't have to, you probably shouldn't have the bobble. It should look sort of concave as this one does right here. It should look like that, but sometimes you just can't get that. So you settle for the big bobble. But this looks like there could be nothing there. So I'm gonna hit that with just a dollop of solder. Just a little tiny little, just a little tiny little, just a little boop. There we go. Yeah, so there was nothing there. That might have been a disconnected pin. It was perfectly connected before we came here, but now it's better connected. Yeah, there must be other things, but that circuit path doesn't have anything else on it. Actually, that's another point in the proof that the WM8731S that I've installed is dead. I'm hiccuping because I had this like spread on toast for lunch, and it was way more oily than I gave it credit for, and so I think it's causing me to hiccup. All right, let's get the audio cable out of here because that'll melt. And everything is off still, and the microscope is way too close for comfort. Can I trust that my plastic pots aren't going to melt? I think they will tolerate the soldering temperature, but I'm not totally certain about that. We are going to put... Actually, what we should do is use Chipquik for this. Measure again when I take out the chip. Then I'll just get the same resistance value. We were trying to look for a gotcha of the thing being like 6 ohms. I mean, yeah, we should measure again when the chip is out. That'll be fine. It's just, there's nothing else to that circuit that could be going wrong like that. So it's something internal to the WM86 blah 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 that is causing I2C to look like it's only a few ohms. And the only thing that I could think about is that if this is like shorted in a way, because I2C SCA, I2C SDA, we've got literally just the pull-ups, the 2.2Ks, and then if I highlight like SCL, that is only traveling from dot to dot there with the vias here. So unless something is hyper wrong with these vias, I don't think there's really much to these runs. What's going on there? Oh, that's power. So measuring this in parallel, you're going to two microcontroller pins on the other side of that resistor. That might mean that might be the reason why WM whatever is dead, or it might be part of what's happened to it, I guess. If I found a low resistance on it again, then I guess, yeah, that would mean that maybe the STM is the problem. So, all right, let's get this thing out of here. So in order to do that, if I'm just purely using hot air to remove it, I can just load this thing up with flux, maybe a little bit of solder, but mainly just load it up with flux. If I want to use Chipquik, if I want to be kinder to all of the plastic that's surrounding this, what I would do is put Chipquik down each of these banks, and then it would probably just fall out at that point, and then you got to do a lot of cleanup. And I'm actually pretty tempted to do that with this because we are in very close proximity to a lot of plastic. If I do hot air and it melts my pots, I'm gonna cry, but I have more pots. And I don't want to remove the pots because it's such a pain in the butt. It's such a pain in the butt. I don't think I'm gonna melt anything if I'm careful. That goes on, life goes on, solder goes on, flux goes on. Oh great, it's gonna smell like burning hair now. Flux, this is tacky flux, and so any stray hair particles or dust particles will find their way onto it. But yeah, this is this stuff that I use. I'm gonna order more of it because we're actually starting to run low. And then I am going to begin heating this. I will eventually put the tweezers down like this. I gotta be really careful because that capacitor is also going to want to come with it, but I should be able to just move it. Yeah, this is a shop. This is kind of a wood shop, but for electronics. So it is these similar levels of cleanliness to a wood shop. There's a dog that sleeps under my desk. She is my boo. She's my world. That dog is so cute. Her name's Willow. We've had her for 4 years. I've not lost any weight yet. I've got all of these wonderful drugs trying to get me to lose weight, and I haven't lost a single pound, but my response to insulin is so much better. This is a quick 861DW hot air rework station. My viewers bought it for me. Very kind of them. And it's got the Louis Rossmann 45-degree angle tip, which is apparently incredibly expensive. Apparently it is a luxury item that they bought for me because they were going to buy me a 3D printer, and then I was going to get a 3D printer from a friend. And so there's a little communications confusion. It's the reason I have a Discord, is actually they wanted to coordinate people donating. And some viewers that I wasn't aware of donated quite a bit of money to that fund. And they bought me a bunch of joke gifts and that hot air station. The hot air station is awesome. It's really, really good. Well, I could have just plopped down another chip. I really want to take a look under these pads first. It's hard to get into because there's stuff all around it. Yeah, so it's just silk screen damage on most of these. Just gotta make sure to move the solder braid with the iron. You don't want to separate them because then you can accidentally pull pads. All right, let's clean this up. I don't know the brand. Not confident enough yet. My future plans feel like I can't responsibly own a pet. Well, that was my situation, is when I had the good jobs where I had the money to get the pet. And the money to get the pet, I was a single guy living in an apartment, working most of the day. It would have been cruel to an animal, and I decided against it. Now that I'm here streaming, life took a whole bunch of turns. I don't want to go over it right now. I'm here, so we've been able to raise and train the corgi to be. I mean, she's very corgi-like. She doesn't listen. She barks all over the place. She's a bit of a kooky personality, which is good and bad things about corgis. She's been an absolute joy to have here. She's been wonderful. She's my best bud. We were hanging out earlier today. But she also gets me outside and walking, which is very nice. Oh, we got an ad starting soon. So before I get into this, we'll let that ad play out. Are those two supposed to be connected right there? These two. Those two look close. All right, I'm gonna let the ad play. We still got about 2 minutes. I could snooze it for 5. This is like a psychological thing. Yeah, those two are supposed to be connected. Those two have clearance to have something between them. These two don't, but I don't think there's anything there. Why? Oh God, it's still hot. I was like, why was there a burning sensation when I put my finger on that thing? The thing I put that place that time? Actually, no, there shouldn't. That's not hot at all. Weird. I don't know. Did I ground something? I'll do that in a sec. Jeez, give me a chance, man. My show. So these are the ones that are supposed to be. Oh, the top of this knob is hot. That's what it is. Oh God, it's like screaming, burning hot. Yeah, look at the thermals, bother. Jeez, why do you have a thermal camera if you don't even use it? I was wondering why I was getting like a burning sensation. I thought I was getting like a ground fault. Okay, that's just a stray. Oh, oops, sorry. Stray bit of solder mask. All right. I don't know if I'm going to show off drag soldering. I don't know if I'm going to show off drag soldering with this or not. I think we're going to do individual pins just because I can control that so much better. If I do individual pins, they're probably going to have too much solder on them. But yeah, all right. Let's just do a double. I have been jabbering for like 4 hours. 3 hours and 30 minutes. Okay, let's check the resistances. Gibbering on for the amount of time that streaming takes is a quite a thing. 1K? Why are they both 1.142K? 1.1? What? It's whatever the STM32 is doing to... Well, okay, so test number 2 is to turn this thing on and see if we see communication on I2C. I2S, whatever. Why are they at 1.1? Maybe it's not the codec. Maybe it is the microcontroller. Faction, are you an alt of that person from earlier? How's it going? Okay, was that the ad break? The ad break's starting any second now. Any second now! Hold the line! I don't think it's both. If it's both, I'm going to be annoyed. There's our ad break. We'll be back in just a sec. After these messages, we'll be right back. I'm going to clean up around these because this sickens me. Flux. I hate flux. It's disgusting. Just going to give that a little drop. Oh, that went to the wrong part of the board. Okay, let's soak everything. That's fine. Hit it all. Let's dry that up a little bit just so it cleans up nicer. All right. Disgusting board. I really wish these were not white circuit boards because they show off all of this grime so well. Green would be much better and better looking and I'd feel better about it, or something red, blue. Yellow is a very nice color, but the white circuit boards that I keep getting from Modular Addicts, I despise. I really don't like them at all. They're hideous to work on. I'm going to wait until we come back from the ad break to do this digital test. We're seeing whether or not I2C is working, because this module, I put it together and it seems to do stuff. Like the brain works. I seldom hear of a microcontroller failing in its individual parts. What would have happened, those I2C lines were only exposed to the digital communications between two chips and the voltage and the resistor. But the resistor values are fine if we remove one piece of them. If they are connected to the main microcontroller, we're like half the value of them. So there might be some internals of what the STM32 is doing, but either way, we have one chip out, the one that we thought might have been not really participating in the whole thing. If the other one isn't participating, that's an expensive chip, and that's a 10,000 pin chip for me to get out of there. It might just tank this module for the foreseeable future until I'm feeling like I'm willing to do this kind of solder rework again, which is always, but I mean, it's still a pain in the butt to do. Programming it is even worse. You have to set yourself up with the STM32 environment on a virtual machine in order to load up the hex file. Although I'm wondering if Platformio can do it. I haven't done much with Platformio, but the STM32 stuff that I'm going to be doing for the steering wheel project, we're going to be using the Platformio Arduino tools to load it up. I also use Platformio to do my insulin pump software, my feedback loop pump stuff. Since I've been doing like the Ozempic and the you know, all that stuff and automating my diabetes and everything, my glucose level responses are amazing. I go hyperglycemic way less. My deltas are like legendary apparently at my doctor's office. So it's been kind of an amazing thing. The one thing that I would really like is to lose weight, and it's not happening. I don't know if I need to couple it with exercise or what. Ah, there's our indicator that we're back from the ad. Welcome back. So we're going to power this thing up. I'm gonna probe around these I2C lines to see if we see the microcontroller attempting to communicate. Now, that could all go crashing down if there's something in the code that says, oh, if you can't communicate, just stop. I don't know why you would do that, but still. Stupid question. If the STM32 is that much of a pain to program, why choose it? Good question. I can't answer that because I didn't choose it. I chose Mutable Instruments hardware, which was designed in 2015. And since then, I guess the chip, you know, we've had COVID, we've had all kinds of weird stuff happen with chip supplies. Why use an STM32 in the first place? It has 1 billion I/O pins on it. It has like 1 billion pins, and it's like stupid fast. It's like a whole computer. They're really, really, really nice. Yeah, for robotics and control too, because they're so fast. With control systems, and you're doing a lot of feedback loop, control systems and robotics are the same thing. you're doing feedback loops and stuff and you really want things to be fast and snappy, that's why people choose that chip. For music stuff, you want to be able to be putting high quality sound out, and that takes a lot of breakneck timing in order to do that, especially if you're processing and outputting stuff through like a filter. So I guess that's the decision. It was just those were the WM8731 and the STM32 were more available at the time. I'm here buying circuit boards off of Modular Addict, and Modular Addict often has the old version of a lot of this hardware. So I'm sure people have updated the design since then. There's equivalent WM8731s. There's more fast microcontrollers now than you can shake a stick at. There are probably updated versions of these. I think I've seen one with a through-hole STM32. Like, better things do exist. I decided to challenge myself with this soldering of absolutely teeny tiny stuff, as well as putting together sort of a production-worthy board. So this is my own, this is the oh bother challenge, basically. I've inflicted this upon myself. If I were a little bit more in the know, and if I was a little bit better at sourcing, I could probably get one that's a little bit more advanced, DIY friendly, but not completely, utterly aggravating like this. Stop telling me what to do. It's the number one thing that drives me absolutely fucking nuts, is that people think that I don't know what I'm about to do. Bother, shouldn't you turn on your module tester now? Bother, use your right hand to grip the probe. Oh my God. I'm good, man. We're getting there. I got a lot of stuff to get through first. All right, let's zoom in on this thing so that we know what pins we're looking at, because we might need to look at this from the very beginning of boot up, because it might just look for it and say, "Ah, you're not there," and then F off. Oh, this one. Sorry. Let's focus in on the arm too. I don't know if that's in focus or not. It's too small. Okay, so these pins are, oh God, they're so small. Everything is so tiny and there's so many pins on everything. 1, 2, 3, 4, it's 5, 6. So this one we should see a signal on. If I do this. Well, it came up. I don't know if we lost it. I would expect to see a little bump. Up to now, I had good luck with the STM32 Cube programmer software for hex files. That's true. I do have the STM32 Cube software. You're right. I probably don't have to run that environment. Where's our I2S? This appears to be the same thing that was happening before, huh? I'm quite annoyed. The 2 pins down from here. So doot, we're here. Nothing. Clock. Oh, so we're not even getting that. Yeah, pin 1, 2, 3, 4, 5, 6. Before we were seeing something here. Now I see nothing. I have one of the knockoff STM32 programmers, but I have used that through the SimCube software to load hex files. I have done that. Could it be that I got a bad hex file? Don't like to use vendor software, especially GUI stuff for the microcontroller programming. Personally, I like it more when I can have a make file or something with the command line tools. I'm not used to using make files. That's my problem. Oh, so it doesn't even do its little dance. It just came up with an error. Yeah, so that microcontroller seems to be working, but our I2C seems to be flat. But also, we had it do a little dance. It did a little LED thing, whereas now, we don't get that. Which one of these is reset? That's this one. That was not reset. Yeah, I am late to the game when it comes to doing this stuff. I actually think I do have that programming header though. So we could throw this. Oh, I did sysboot, not reset. Reset's the lower one. Well, let's turn this off and on again. And I missed it. I was looking at the other stuff. Hit reset right here. Doink. Yeah, we just get all blues, which should tell not me something is going on. Well, let's put a new codec in there and let's see if that fixes it. And if it doesn't, it might mean that I need to reflash it, maybe. Because something seems to be like messed up. There's no I2C communication. How much is it going to do? We probably should be seeing it do stuff though if I'm hitting it with a sine wave. At least today, what we were able to do is verify that that sine wave goes all the way into the codec. Yeah, so the I can also load the hex with Platformio. Probably can also run it through some test stuff. But again, the STM32 was like a lot. It was a lot to like learn and deal with. And when I was doing it originally, I did it through the instructions that they had on 4 mutable instruments, you know, designs. So what I ended up doing was running an entire like test environment. It was like a virtual machine kind of deal. And I had to do all that stuff. It was a lot. It was a lot. But actually, that would be a really great way to do things, is to just have each individual microcontroller project have its own virtual machine. That way, when you're installing weird drivers to get weird programmers working, it's okay. But then with the advent of like Platform IO, that compiler is kind of amazing, isn't it? I haven't really used it, but it seems like, you know, if I'm programming an app for my phone on the same thing that I'm doing STM32 Arduino stuff and anything else under the sun, it's kind of cool. All right, so anchor pin. Anchor pin. Anchor pin. Ah. My little flared tube, brake tube solder dispenser sometimes pulls a little too much on the wire. I feel like I need to get a flare tool and fix that. It's all like rusty. It's got like oxidation over the tube. That used to be shiny. It's possible the original chip was fine, but I'm gonna swap it anyway. I just never heard of a microcontroller losing individual systems. It's usually like all in one, and like everything is dead. Actually, I should probably do this as the anchor. It'll be easier for me to get the iron on. So we add a little bit of solder to one of these. That was really controlled. I like that. And then we slide our chip into place. And so our little bit of solder there is going to hold us in position. I got to get it so that I can actually jockey the chip around. Which means going vertical, which means blocking the camera. I give it a tap on top of the chip just to make sure that it's flat. This is where you need big muscles to do this stuff. Oh, the capacitor's getting in the way. Let's slide down. And when I say you need big muscles to do this stuff, it's because you're stabilizing. What is going on? Why can't I move? I'm hitting the knob. I need to go more vertical. Jeez. You guys can't see anything. It's just, welcome to Flash Cam. Hold on one sec. We're gonna get out of this operation. Jesus. I think the chip is so old that I'm not getting solder to stick on it. I'm still using CubeIDE a lot because I had to learn GDB command line interface. What is that? GDB. So yeah, this is like very difficult to maneuver inside of. Let's get the solder out of the way. Actually, I'm gonna dab that pin with flux. I haven't done any step decoding. I hear Arduino has that now, and I've got a bunch of projects where I'm using an STM32. I really need to like learn how to, because you can step through your stuff and like, I don't know what I do. I'm not much of an embedded systems programmer, but I have had to interact with embedded systems a lot. I've gotten better at it naturally, just by virtue of necessity. Probably like take an embedded course. That capacitor is pissing me off. It actually is in the way. Okay, do a flip. Do a barrel roll. That's fine. We'll do barrel rolls. We'll just flip. It's cool. No, you wanted to do it. Rip capacitor. I should have nudged it upwards when I had hot air on it. It might have been that this soldered over and it was originally nudged upwards, but it's too big for its britches. And so when I heated it with hot air, it moved down because of surface tension and got a little bit too close. It seems as though that is the case. And I may need to scooch. Yeah, we gotta scooch. We gotta scooch. Don't worry about the one above it. Don't worry about that one. How am I gonna get you to scooch? We might just remove C29 for just a minute here. Yeah, I've got the right capacitors now, but back then I didn't have the right ones. So I just kind of snuck them onto the same pads. These are decoupling capacitors, which aren't strictly necessary, to be honest. There's been a few articles lately that have said, like, put the biggest capacitor you can find there, not physically, value-wise. Put the biggest caps you can. You don't need 0.1s. There are better values like 2.2, and we've gotten better at making small capacitors, so it stands to reason that you could put a much larger capacitance capacitor on your decoupling caps. They're really there for time equals 0 when the inrush of current initially hits your circuit, so that things like a microcontroller or more complicated electronics don't come up piece by piece into functionality. Because you have part of your circuit will be able to function under different voltages. There's Willow. She's asleep in that picture. This is not moving, and I'm mad. Please move. Please read from sheets. Get out of my circuit. There it is. You sit over there. Think about what you did. We'll bring it back in. What's up, Haystack? How you doing? What is this YouTube? I'm not going to click that. I'm not going to click that. It's a mobile YouTube link. It's in cap jail. What the? Stop doing flips. Oh my God. I keep bumping into this wire that's up here. The testing wire, and this thing is like burning. I'm seeing smoke come off of it because I'm holding my iron up and it's just colliding. Get out of the way. Okay, I have to hold all my tools like this. It's like laparoscopic surgery. I was looking at laparoscopic surgical tools to see if I could actually make my life easier and have some kind of an assist for doing these kinds of maneuvering things. I don't know if that's a problem, and it might be a problem. I might need to replace that with an electrolytic capacitor. I don't know why I did that. Probably because I don't have a 1 microfarad electrolytic that's small enough to go in there. And I should probably, in the convening months and years, have sourced one. But I didn't. So we're here now. That's not in place. Hold on. This needs to be pretty accurate because I'm not going to use hot air to solder this thing in. Why is it not? There's a potentiometer in the way. There's a capacitor in the way. Everything's in the way. Makes maneuvering this thing much harder than it has to be. Oh, and then I'm on top of the cap over there. Son of a bitch. Oh, that got right in the way of where I was looking. Good timing on that haystack. I stick my finger into the tweezers in order to release them. Now, that's not looking too great. Just deform the metal on the one pin a little. So that this thing will sit right where I want it. There we go. Oh, and I've been melting the... Ugh. What is Pete and Pedro, and why does it have nothing to do with what I'm doing right now? What is it? What is that? What I need is the Da Vinci robot. Because I think with the Da Vinci robot, I could pilot it, and I could win in a mech fight. Because it has missiles. That worked really well. That was really amazing. All right, we're gonna Rossmann this shit up. Yeah, Da Vinci robot for soldering. For basic solder rework that could be done using a drag soldering operation. Yeah. What do you mean? I need a $2 billion robot to do this. Just put it in the expenses. It's, come on, man. You can write it off on your tax form. It's practically free. Grapes is getting better health care than the rest of us out here. They got robot surgery on those things. Those grapes get all kinds of cosmetic surgery. I don't think that was necessary. You think insurance covered that? Ah, go in but vertical. If you do not go in vertical, you will melt all of your stuff. We'll go over that one again. That just means that the rest of them are now, hopefully, solid in place so that this thing doesn't move. Yeah, okay, good. That might be a cold joint on that, but it at least holds it in place. It's a tax write-off, yeah. Pete, Pedro, and Willow. I don't even know what that is. What is that? Nobody's like explaining it, so it's like you sit here with your stream going, and people come in and go, "Hey, have you heard of Pascal and Bibbidi Boop?" And you're like, "I don't fucking know anything about anything." "Hey, Bother, did you hear what just happened in the news?" "No, there are logs. I've got receipts. I don't know." And then they just go away. They go, "Hey, did you read this professor's paper about..." This thing is over to the side and it's driving me nuts. This is driving me crazy. I can live with it though. It's right on top of its own pins. This will still solder okay. No. I gotta live with it. I gotta live with the fact that it is totally to the I can't. I can. Ladder logic? Nobody's using ladder logic anymore. That's from piping diagrams. Oh, so that's what it was related to ladder logic? I don't know how much, what systems are still using ladder logic. Not many, though. Elevators, maybe. For PLC stuff. That's not Pete and Pedro. Wait, what are we talking about? Oh, you guys are talking about something else. Oh, man. Okay. Stop paying. I'm going to stop paying attention to chat right now because they're being a bunch of weirdos. You guys are stressing me out. Because none of this stuff is going the way that it should. That's a totally different problem. There's plenty of technologies to get the ladder logic out of your elevator. That pisses me off. See, instead of going on the pin, it just balls up the solder with heat. That's really close, but I think that's okay. This thing being so crooked is what's going to get to me. And I'm putting way too much solder on the individual pins. I think we're probably better drag soldering this. I think that would make it a little better. because this is getting a little sloppy here. I'm not able to control the amount of solder that I'm putting into these pins. I guess I can go back over it with hot air, and it'll kind of maneuver itself back into place. But we are getting a decent joint here. It's just, this is so small. It doesn't look like it's small. It is very, very, very small. Smaller than I'm typically used to. So it's a little harder to control what goes in. Because really, I just want to touch that tip of the solder to that pin and have it flow all around in one operation, which I got a couple of them to do, but they're kind of fighting me. And I do have a wedge tip, and I could drag solder it. It's pretty much what's called for here. The best way to make it look okay. Iron's still on, iron's still on. My iron will turn itself off. Thinking it's saving you from a fire. Oop, slipped. Here, get that. Clean off the tip. We got to go totally vertical on these because there's too much plastic stuff surrounding them. Too much. See, it was really too much, and all I want is to diminish the look of that foot. I want there to be a taper, like a filleted amount of solder on it, and just barely like a little moccasin on the foot. Oop. Got that mock drip. That was way too much because I tapped it 3 times because my hand shook. So much so that I still had enough on the iron to do the next one over. That was too much. And then that one's already soldered, but I need to get it up above. There we go. Okay, so sloppy work. Sloppy work. Passable, sloppy. I kind of want to take hot air to it, but I don't think I need to. None of them appear to be hitting anyone between. We know that there are a couple little cosmetic marks that make it look like some of the pins are connected to one another, but we know they are separate. So let's put that capacitor back in, and then we can check to see whether or not this works at all. And if it doesn't, the only other piece on this little chain of audio here is the STM32. F104. That is not cleaned off. Where's my other desolder braid? I have 2 of the things going. Here it is. Ooh, I'm gonna get a sore throat, I think. That one swallow that tells you you're gonna have the flu tomorrow. No, I think I'll be okay. Tomorrow is going to be a crummy, rainy day, so we are going to be able to get a lot done. And maybe we will characterize some filters. Not really necessarily going to do a Bowden plot, but I might be tempted. Bowden plots are neat. They tell you when all of your stuff is going to be unstable. I am not getting in there for this. Hold on. Let's try from up above. I don't think I can get enough heat. Angling. Pivot. Still not as clean as I would like it to be. Well, as good as it gets. 10 out of 10 UV index? Jeez. That is hell. I think C28 I might need to replace with a 1 microfarad. But the only 1 microfarad I had was ceramic, but it's non-polar. It may need a polar cap there in order to block whatever it's supposed to block. I don't think that's a showstopper. That's not what's causing our digital communications to not happen. And I fear that the digital communications not happening might be down to the firmware that I loaded up. But at the same time, damn it, fuck. Just dropped out of my hangers. The digital communications not happening could be down to something else, though. Futures AI. What are you guys talking about? Yeah, like with the hot air, that cap shifted. I was just a cap. She was just a chip. Couldn't be anything more to it. Why is that being weird? Look at how weird that's being. Let me just hit it with flux and see if I can fix it that way. You take this. There's way too much solder on it, but whatever, I don't care at this point. Okay, who cares? That's soldered back in. It's a decoupler. It doesn't even do anything. It really doesn't. There have been a couple like studies of having decouplers, not having them, or having them be huge values versus being the typical 0.1. 0.1s are, I mean, they're available all over the place, so I guess that's probably what's going on there, but you can have much larger capacitors and your circuit will be happier for it. Okay, we'll power this on, see if we get anything out of it. You know, while it does look pretty sloppy, it's fine. It's fine. Everything is there. I would love to hit it with hot air so that it could shift over to the right a little bit. I would really like that, but I don't know if that'll actually happen, so. Yeah, so here we go. Gave it a minute to cool off. 3, 2, 1. Actually, let me plug our sine wave into it. Sine wave into R, and then hopefully those LEDs indicate to us a volume level of some kind, because we've got it maxed out right now. 3, 2, 1, go. Okay, we're back to doing the actual sequence. So let's take a look and see if we've got communication on the I2C lines. I need a ground. Make sure I get a ground. And we go to these little guys right here. No communications. No communications. Could it have already said its piece? But if I turn this up and down, it's like the behavior of the DAC. Yeah, see here we're cycling. That's doing something. Then it turn off. And then on output, we're not plugged in. We don't have any. Just check to see if these are doing anything. Where do I pick those up? Those are somewhere down here, right? Okay, hold on. Output is coming from, well, I mean, if there's nothing communicating, that's a clock. 4, 5, 6. This is a communication of what audio. This is the other clock. That actually looks like something complicated is on there. Oh, wait a minute. Wait a minute. Let's see. Ground, L in, 9. Where's our output? L out and R out are on those 2 pins. Do we get L out and R out? Welcome to the most frustrating thing in electrical engineering, which is when your design doesn't work for some reason. You have to find that reason above all else, and sometimes nobody's there to help you. There is a voltage level on L and R, but there is no audio, which could be down to whatever I'm doing with the rest of the filter. Just twiddle some knobs here. Give me one sec. Make it wet, make it dry, and I slipped, and then the whole thing fell. What the fuck? Hold on. So yeah, I have absolutely no idea what is wrong with this. The output from that DAC, it seems like it's something between our microcontroller and the DAC. And it seems like the DAC is actually functioning a little bit more now. We have some kind of communication happening on more of the lines. I'm going to get this so that you guys can see my hands a little better. The brightness of the circuit board really bugs me. I hate it. I hate it. I hate it. Can I move this in some way? Yeah, that's going to look a lot better. It feels like we took a baby step. It doesn't feel like we definitively went, you know, objection and everything. Everybody in the audience gasped and we said, we know where they were. And you know, now everything is different. No, it doesn't feel like that at all. Instead, we have a minor amount of additional functionality. So we see that some of those pins are actually outputting stuff. So I'm actually going to switch to the left channel and see what that does. And see if probing, God, we've been zoomed so far in. If we've got audio here, okay, nothing. Oh, it's off. Yeah, turn it on. See, that's not audio. And then pin 6. I really need sharper probes for doing this. Nothing. Signal. 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 And those are... See, there should be something all the way down there. Oh, left-right clock is all connected to left-right clock, and that's, what is it? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Ugh, damn it. Cables are getting, the ground lug is getting in the way. Okay. 1, 2, 3, 4, 5, 6, 7. That's LR. This one is SN. Nothing is coming in. This one is out. We have something that's defining out. And this one is clock. We have nothing communicating input, but over here at the inputs, and I gotta, hold on, I gotta use the CAD program here. LN and RN, 1, 2, it's a 15, 16, 17, 18, 19, 20. There's stuff in the way. There's stuff in the way. There's stuff in the way. Pin 20, pin 19. Pin 19, we have this like really disgustingly distorting signal coming in because my module tester is a little bit hot. So we're definitely giving it an input, but this thing isn't communicating any kind of an output. And then if we look at I2C, which is like I think up here a little bit, well, these are I2C. There's like nothing going on I2C. What is going on with you? Oh wait, no, it's the other side. Hold on, other side, wrong side of the chippy thingy. So that says there's nothing. Although an I2C, we're not triggering off of it either. So if I've got my trigger, I'll put that on channel 2. You guys can't read that. Channel 1, you go to channel 2. Okay, so now we're triggering on I2C, and I'm going to speed us way up. I see no sorts of communication. What if I change modes? No, no communication on I2C. Let's check the other one. Change modes. No, no communication is on I2C. So I'm willing to believe now that it is in fact the microcontroller that is the problem here. We've got everything going into our audio codec, but we've got perhaps nothing communicating with it. I'm just twiddling knobs to see if anything... Wait, what was that? Something happened. LEDs did something. Yeah, so if I move this knob, I do get some kind of a thing going on. Well, that one charges up. These all control different stuff. I'm just testing this. Don't know what this means. What if I turn it way down? Nope. Turn it way up? Nope. What is that control? Hold on. Blend. So this is blend, texture, density, size, position, and then our gain. And these are the blend modes. I see. So I'm jumping between whichever LED is lit up is the one that I'm sort of controlling the blend on. Huh. I don't know what's wrong with this. We should probably go to characterizing filters tomorrow. That'd be a good weekend task. We can do a little frequency sweeping together. How does that sound? Does that sound like a good time? Doesn't matter. It sounds like a good time to me. Trigger menu. Let's go back to channel 1 so we get a little bit of stability on our waveform here. That way we don't have to deal with digital systems. And didn't mean to deal with digital systems today. We didn't really do what's in the title. We mostly just resoldered clouds again. Last time we hot aired the microcontroller back into position. Now we actually replaced the codec. And although it seemed like more things were doing what they should do, nothing is happening in the filter. It doesn't appear as though there's any output audio, which means trouble in paradise. Something is wrong. If I plug in an output, we can take a look at if there's any output. Let me just do a quick little... But yeah, it just seems like it just doesn't want to work. And it could be, I mean, maybe I loaded software into it badly, or maybe... You know, I don't know. I thought I got the good software in it. Which one is left and right? Out right, out left. In L, in R. So we're in L, so we're out L. And it's a filter. Turn the gain way up. Doesn't matter about the blend. I should be getting something. This is supposed to be like a really cool filter. Clouds is supposed to sound really cool. But I don't know what's wrong. I mean, these aren't cold joints. Those look perfect. Except maybe that one, but that's not involved. It's the ones up here, the midway here, pointing device. These ones up here are the ones, and they look perfectly soldered. It's like these right here. That's perfect in every way. Could the STM32 just have had enough of a bother, and it just decided, you know what, I'm done? Because you know, it seems like if this thing were okay enough that it's still functioning, I'm seeing it, it's blinking the LEDs, then we would be seeing something else going on down here, and you know, we would have been able to look at the other parts of the circuit, like the output circuit, whether or not that was functioning properly, but I mean, this just is not participating. What are you? You're an LM1117. Yeah, it's just flashing is going to be like painfully annoying. Wait, why are we in... Where'd my stuff go? Oh, we're in the wrong scene, that's why. Blink. Huh? 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 Oh, I'm not grounded. I'm not grounded. I'm not grounded. I'm not grounded. About to have a huh moment. Huh? Powered on. LEDs are doing their thing. Probe's not plugged in. Probe's not plugged in. Probe isn't plugged in. Probe isn't plugged in. Probe isn't plugged in. I put the other plug in there. We had no probe. We had no probe. There we are. Yeah, we're functioning. It's just fine. Everybody's fine. That is above. Yeah, it's 12 volts. Doink, 3 volts. Doink, 3 volts. Okay, so yeah, all our references are fine going in there. So C28 probably will need to be replaced, but I don't know what the problem is. I think maybe flashing it again is the first step along a journey of flashing this thing over and over again in order to get it to work properly. That's our negative 10 voltage reference. Working fine or hardly working. Everybody else seems to be okay. That's really 3 volts. It's a lot of 3 volts. 12 volts. I need to find either the hex file or get that environment working again so that I can make the hex file for Mutable Instruments Clouds. I'm going to see what that... I'm going to look into that and see what that takes. But man, this has been a very frustrating, very, very frustrating. And the fact that the LEDs work mean that the microcontroller should be in just perfectly fine shape. See? LEDs work and they do all their stuff. All the complicated functions depending on what you're doing. I can make it go blue. Listen to me, chat. I am Mesmer, here to mesmerize you. Look at the blue and the green. I use blue-green combos because I found them and bought them. I am completely flabbergasted. Usually we're pretty good at troubleshooting here on this stream. Usually we're pretty good at that. We know how to eliminate many different factors, and experientially we have hundreds of years of experience doing this kind of stuff with all of us going all in. Also, just remember that Beckhoff lets you embed C. Who, what? You guys are talking about something I don't know. So I could either plug in this little guy over here. I could plug in this TX and RX thing. Supposedly you're able to put audio into this and actually get it to program with audio, and that's what we originally tried doing. We couldn't get it to work, and the reason was something is wrong with the codec. And it could be that something is wrong with the STM32, something is wrong physically with the STM32, it could be something is physically wrong with our codec, although we swapped codecs, so I don't think that's the case. I just don't know. I know, something to do with PLCs, but I didn't bother to read it, so I'm left behind. I was hoping we would be looking at the other parts of the circuit, like the other analog parts. We did a pretty decent job tracing our signal into the device, but we can't trace our signals out of the device without something happening here. And I guess there are other parts of filters. You need other signals to make filters work. We could try to inject some of them. If there's a gate that we need to do, freeze, trigger, position, size, volt per oct. What is, I mean, volt per oct, I don't think that's going to do anything. But we do have a trigger. I don't think that's it either. Inwrite, density, text, texture, and blend. So if I wanted to control this, probably should use a longer, let's use a longer. There's a lot of texture in that. volt per oct. And this. And then let me go back from the probe. We're going to undo the probe. I'm going to put in my output monitor. I do probably need to hack this scope soon so I have full functionality. Where did the BNC go? Somewhere around here. So much drama in the BNC. I'd be shocked if we actually saw something happen. Yeah, I guess this powers down after a little bit, so it doesn't show you what's happening. Nothing. But it has to, I think the microcontroller, because we're using I2S. If you guys don't know, I2C or IIC. I2C is integrated circuit communications. So you would have a clock line and then you would have a data line. I2S is integrated circuit sound or something. It's the sound equivalent of I2C. It's for very quick communication between chips in order to maintain audio. Talking about PLCs and the programming of such. No, it's okay. You guys don't have to stay totally on topic. I might harangue you and you will be the target of ridicule if you drift off of topic, but you're allowed to drift off of topic. I'm not one of those creators. I'm not like policing you guys strongly. You guys just behave on your own. Man, I'm more of an advocate of the old Twitch where people were posting links to furry porn and stuff in some, this wasn't my channel, but it was somebody else's channel. But man, those advertisers really got us tied up, don't they? If no input, I would check the powering source for the STM32. Well, okay, so listen. Oh, you can't see that as easily as I can. Oh, and it just, I said listen, and then it ripped them away into an ad break. Are you using scripts, Dorf? Can you still hear me? Oh no, we lost Dorf. Just when I was gonna say something to them, I was like, listen, and then I died. I went to an ad. I streamered them. I'm always right because I'm the only one that can talk. So what you're looking at right now is me doing the little cutesy things that the microcontroller does. I can select these 4 blend channels and I can change the blend by twiddling the knob, right? And it's remembering my settings. So in just doing that, I have been able to prove that the microcontroller is fully functional. Oh, you guys had a very short break. See, I get a full 3-minute delay because Twitch said that it was a 3-minute ad break. Twitch said that, and my tools have now kept me in limbo for the full 3 minutes. I don't understand how you guys have these variable ad breaks. If it was a 5-second ad break, then my tools should let me know, but the Twitch API doesn't. Right, yeah, so the things that people don't notice me do, it's regionally dependent. I see. People don't notice you do these things, and it's been a lesson for me to learn to like stop and break down exactly what's going on to everyone, because they won't notice me do these very quick things like, if I press the button and I see something happen with the LEDs, that means that the microcontroller is functioning, and so all of these controls also function as well. And the thing that I really wanted to, God, that hiccuping is really killing me. The thing I really wanted to troubleshoot was the things that come after this chip over here, which is the codec. Trust me, I noticed. You noticed. You've been here the whole time. You're the only person that's actually plugged into the stream and watching it. Everybody else is like, has read it up on the other page. Anyway, no, it's fine. It's fine. I love you guys. So yeah, we replaced the codec chip, and that seemed to make things communicate a little bit more. I saw more of these lines over here actually sending 1s and 0s. Now, in terms of like setting up the chip to function, what do we need? I mean, we need ground and power. So that's these 2 at the top. We'll just check these. Or let me get this plugged into like channel 3. We'll do our like digital testing on channel 3. Get channel 3 up. There we go. Channel 3 is nice and purple. Make it purple. Oop, too few. Let's go up there in voltage. Up. Let's go above millivolts. Maybe we'll go above millivolts. All right, so 3 volts is the top division. Ah, we're back from the ads. Oh my God. Welcome back, everybody. Whoever designed this should have added test pads. In post, I mean, that makes sense, but if you get somebody else to assemble it and you just load it up with software, maybe nobody really needs the test pad. I don't know. You should always be testing, though. Okay, so the power for the chip is 3 volts. So I don't know why I have so many WM8731s. They must have been real cheap back in the day, but I think I stole these. I think I took these from an old employer that used them in their devices. I think that might be the case. But anyway, that's at 3 volts. This pin is at 3 volts, so that's our 3 volts. Ground, of course, we're ground reference, so we're not going to see anything happen there. Do we have any other like references in here? Let's see. Pin 2 is unlabeled. 3.3 volt A is on pin 8. So let's check that out. 1, 2, 3, 4, 5, 6, 7. What bothers me is that we still see the LR clock functioning perfectly fine. Oh. Hey, buddy. Hey, buddy. This one's ground. Ah. What's going on here? Am I on the right? 1, 2, 3, 4, 5, 6, 7, 8. Donk. That should be 3.3 volts, which would be all the way up at the top of the screen. 1.2 or 1.8. It says 3.3 volt on the schematic. Could you be the problem? My lack of ceramic capacitors may be biting me in the butt here. 3v3A, 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 3v3A. That is down to this guy, which we saw 3v3 at. But why here we see 1.8? Why we see 1.8? Why we no see 3v3? An extra ceramic capacitor between friends should be totally fine. Especially on a line like this. But it's definitely not at 3 volts. Oh wait, hold on, double check. X1, X10. Damn it. I flipped the switch. I was pulling the probe away and I must have flipped the switch. Okay, so our voltage reference is fine. It's fine. It could probably use a couple good caps in there. I gotta find myself some of these one-off tiny caps. But no, that's fine. Everything's fine. Everything works. Everything is perfectly fine. Everything works perfectly. Except that it doesn't. Except that it doesn't work. It's not working at all. R out and L out should have something outputting on them. And we get nothing. Good day to you, sir. We get just a static voltage level that's in the middle of the 3v3 range. We should be seeing waveforms, but we're not. So something in this chip is doing a fine job of setting it up. There's just no data coming in. So it is the microcontroller that's screwing us over here. And these go to which pins on the micro? Just send anything, bro. Just send anything. Come on. So there should be something coming out of here. Brrr. That's actually, what is that pin? That pin is left-right clock. We speed it way up. Our left-right clock works just fine. There's a special left-right clock that's added to I2S. And so this one is serial clock. So that's much faster. We'll speed up a little bit more. That's serial clock. There's a little overshooting going on there, but it's okay. SCK. Next is I2S input. Hello. I2S in. Is it getting into the chip? It is not. Wait a minute. Wait a minute. Chat. We may have the smoking gun. Smoking gun. Smoking gun. Smoking gun. This pin right here is not connected. What about you? Oops, right there. Nothing. What about you? Non-smoking gun. What about you? Smoking gun. 1, 2, 3. Which one is that? This one does nothing. I don't know why it's so noisy. Oh, I guess these pins are just going crazy. Smoking gun. Okay, so maybe I go over this bank of pins and make sure that they're soldered. Nice physical problem. Nice of you to have a physical problem. Oh boy, all my tools are so like, they're like bludgeons for this stuff, and I'm surrounded by plastic that'll melt if I accidentally tap it. The thing is, when I did tap to that pin, nothing changed on the signals that we were seeing, so I don't know if that's the entirety of the problem or if there's other stuff going on, but it seemed as though I could get a waveform from the bottom of the pin, but not the top. And if we have input, then we have output. So this might actually, this might solve that problem. Wow, it really took all that solder, didn't it? The smoking gun. Why do you keep saying that, Bother? Well, I have ADHD, and I'm also a streamer, so I have a propensity for annoying behavior. Both streaming and having ADHD are two things that make me very annoying. Aren't you like 40, Unc? Yeah. We're more common than you think. That looked like it wasn't soldered. It looks soldered now. Perhaps that's been our problem this whole time. What else? I think we're good on these. Those other ones look great. So it might have been just like these couple little key pins were not doing their jobs. Hey, could you unbridge those two pins, please? I think maybe that's just a scratch on the silk screen. Solder mask, rather. Yeah, this is like Nintendo. Nintendo loves to use the silk screen to make half of its PCB white for some reason. I guess it looks okay, but... All right, so... Has the module ever worked? No. No, it's a DIY module. All right, let's see what we get here. Let's solder out of the way. I know, right? You're gonna use up all your silkscreen ink. It's weird. They like blanket entire areas of the thing. It might be to make the device look better. I don't know. All right, here we go. 3, 2, 1, go. Why are you not a sine wave? Why are you not a sine? Wait, what? Fuck? Fuck? What the fuck? Oh, because we're going really, really fast. Hold on. Let's go. Slow it down. Okay. Waveform. The micro's working, but we're not outputting anything. Turn it up, turn it down, turn it up, down, closed, open, open. Other channel. Still not working. All right, so let's check our status over here. We'll speed way up and go to the micro. I despise this type of color board. I really am, never again am I buying a white PCB, because this stream has been horrible looking. Look at that. Turn it up, turn it down. That's a signal we haven't seen before. Oh, yes it is. Yes it is. This is extremely fast I2S bits flying around. No, no, we did not cook. We did not cook. We were not cooking. We were not cooking at all. Darn. I was hoping we'd see something. These are just messed up. I don't know what's going on with them. I think they're unmanaged pins in the software, so they're just going crazy. Okay. Turn it off. Turn it on. Yeah, I don't see nothing. Yes, yes it is. It is dangerous, but if they're GPIO, then you're just going to get junk data and the microcontroller will have to deal with it. There should be provisions for dealing with junk data. So are any of the new ones over here communicating? These are really... stuff is in the way. Everything is so small. So those are the ones we saw before. That would be the I2C data, I2S data rather. LR clock, there's two, and those look huge at this speed. And that should be input or output, I forget which one it is. But yeah, we're just not seeing our boy. Where's our boy? And then that's audio out, and then this is, or no, audio out's way down here. That, oh, I think that's 3v3 reference. That's the analog reference, and then these are the outputs. Wait, but those are at 2 volts. Did I flip the switch again? I did not flip the switch. What's our 3v3? That's at 3 volts, but our 3v3 reference, which goes in, okay, hold on. Hold on. We're kind of cooking. We might have something going on here. 3v3A is going in here. That's just the reference voltage for this potentiometer value going into the micro. And then it goes here. And then it goes to pin 8, 14, 13, 12, 11, 10, 9, 8. Okay, that's fine. That one's fine. That's fine. The one below it is question mark. We don't know what those are. Something I can't read. Ground. These are the audio outputs, so they're in the middle. Okay, I don't know. I don't know what's, I don't know, frick is wrong with this frick. This thing is all fricked up. I don't know what's wrong with it, guys. I know everybody's got suggestions, but I thought we were going to be doing a little bit more with like the analog output chips instead of trudging around in this digital hellscape. Unfortunately, our microcontroller feels the need to cut off all communications with our DAC. Our DAC seems to be hooked up perfectly fine. Everything is fine. Nothing is wrong, but nothing is functioning either. Our waveform is going all the way into the DAC, and it's a little bit hot because we're coming in a little bit hot, and this is designed to modulate a variety of signals. So let's say you're coming out of a whole bunch of synthesizer stuff, and you get a long cable, and you plug into this final filter in your setup so that all the other Eurorack enthusiasts will listen to your album and go, that's clouds. That dude just took clouds. That's just clouds. He didn't do anything else to it. You fool. But anyway, so you're hooking it up to clouds. There's a little long cable, and your signal is a little bit soft. And so this is able to kind of cook your signal and make it a much higher. Or maybe you like the distortion a little bit from your normal stuff and you want it to come in there. But what's that funky 3-button mouse that I keep seeing? Ooh, you are not immune to advertisement. You have just been advertised to, bitch. I got you. I got your ass, man. The little light just turned on the 3D connection console. Beep, beep, beep. We got another one. Yeah, so as part of the Fusion 360 creator program, they kind of hooked us up with some higher communications on these companies, and 3D Connection was cool enough to say, hey, we make this like new 3D mouse, this puck mouse for doing CAD and stuff, and you guys are CAD, so we'll send you a couple of these and you give them to your creators. We just want them to use them. They can have all kinds of opinions on it. We don't care. We just want to have them use our hardware. And so the puck mouse is famous for collecting dust, which is what it does here. The mouse is cool. It's configurable. It's sleek. It's heavy. It's heavy because this is 6 axes. You can twist. You can bop it. You can give it a little slap. Ooh, a little harder. It's pretty good. You can twist it. You can tilt it, and it'll move either your camera or the device you're doing CAD on. Very nice and smooth. It's really cool if you're doing a presentation for a client. If I'm actually using CAD, I want the buttons. I want all the buttons. I don't want the no buttons. This has 2 buttons, 3 if you count the one on the back. I want these buttons. So I don't really use this a lot. Kerbal Space Program, for building stuff in Kerbal Space Program, that thing was just, I loved it. You could fly around and put struts inside of your rocket and make it actually rigid. This is the 3D Connection compact wireless CAD mouse. This has an extra button that I do not care for. I was never a 3-button mouser. I used to see people with PCs and they had a 3-button mouse, and what do you do with that? And I never remember what they say after that. This has a decent scroll wheel. It doesn't do side clicking on the scroll wheel. It's just a big old click in the middle. It has this extra button that does not change the DPI. It opens up the 3D Connection menu. You can configure stuff from there. The center click is the same as the center click on the mouse. I'm fine with that. All of that is reconfigurable. It's a rechargeable mouse and I use it wired because my computer's so far away. What the heck? CAD with head tracking would be a shitty idea. I say don't let your memes be dreams. Make that a reality. There are plenty of cheapo webcam head trackers that you can plug into your CAD software, and then you can see if you have invented a new type of hellscape to introduce to the rest of us. What I do like is, unlike the old Logitech wireless mouse, this one has a power switch on it, so if you're throwing it in a book bag, it's not going to like send click signals to everybody and their dog. It works with Bluetooth, but they kind of want you to use their own dongle. It's probably a little faster. And then there's a pairing button on the bottom, and that's about it. It's a good mouse. It's not, it feels nice. It's got the weight of a little bit of metal. I think that might just be metallized plastic. I think that's what it is. But it does have a little bit of a heft to it, and I like my mouses to be heavy. If I could have a chunk of lead that I would use as a mouse, I would do that, because I like my mouse movements to be deliberate. I'm not a young Twitch gamer. I need use eye tracking. Yes. This is what kills me, is that the microcontroller is functioning, and usually that is a binary representation of the microcontroller. It either works or it doesn't. But in this case, it seems as though our microcontroller is working and our DAC is working, but for some reason they're not talking to each other, and I don't know why. We're pretty sure it's not a physical thing. Everybody's pins are soldered and they're planted. And I've seen functionality out of most of this. It's just that one communication line, once we soldered it, it stopped communicating. I don't know what's up with that. Sid Heresy subbed for 3 months. What's up, Sid? How you doing? I got lost in a we're in a mutable instruments hole. I got lost in a mutable instruments hole. We were gonna characterize filters. Today I was going to run frequency sweeps on them so I could tune everything, because I watched a 1 hour and 45-minute video about my oscilloscope and how to use it. So I came out of that video, my brain was pulsing and like glowing, and I now know how to use my scope, and it's a beast. It's probably 600 again. Hold on. I'm going to give Sid a shout out real quick here. Shout out. And it's a Y, SYD, and it's Heresy, like Heresy. Hey, man, no, all good. Sid Heresy does this stuff a lot of the time, but is also probably a much better musician than I am. But they're also another Twitch personality just trying to make it in the universe. Yeah, so those two I2S, or I2C rather, the two I2Cs, yellow channel is our output. It's channel 1 is our input, that's yellow. Channel blue, which is channel 2, is the output, which is on the blue cable. This I was just pumping with a CV, a slow triangle. But our probe is purple. Now let's just quickly put this to bed. Now everything's off right now. $735 ohms. Why is that always so different? Why is it always so different? It's supposed to be 2.2K, but without the DAC in there, it was 1.2. And now it's 850. This is always, it's just always a surprise. It's always a surprise. I think this is here to trip us up. It's 600 or 700 ohms when both the chips are there. What are these chips doing with their I2C? I don't understand why I2C is so cursed. Usually I can probe around and I'll find 15K on the I2C. Yeah, just a random number generator. I don't know what's going on internally with these. They're very irresponsible with their I2C. But I mean, we should be picking up an I2S on these pins here. And if we power everybody back up, obviously my first indicator that this thing is fine is that those LEDs are fading in and out. So that means that like complicated stuff is going on in the microcontroller. We have our, okay, hold on. Yeah, I am too. Would pulling from the UC kill ground? I don't think so. We resoldered these pins, and so we should see our I2S signals on it, and we are certainly giving this thing a signal. We know that into the DAC we've got a pretty hot sine wave. It's pretty good looking, man. I don't want to insult you in any way, man, but you're looking pretty hot right now. That's a hot look. I ain't mad at that. We should be getting something on this, because when I poked into it, we did. Is it broken right here? I was poking in on this mofo, and we actually saw this pin was making babies in the closet, and one of the babies looked at me. Right there. That should be something. This is sin. Sin. This is sout. And then these are just garbled noise. Unsure if maybe I did slip the pin because it didn't look like a data. It looked like one of these clocky things. So why is our microcontroller not even giving a hoot? Why isn't it trying at all? And it doesn't have power over this. This DAC does not have an enable that it would be hitting up. It does have I2C and I2S. But on the I2C lines, and those are over here, we're not even seeing a clock. See, that's at 3, that's at 3, that's at 3. That's not I2C. It's these two right here. Boom. What are you doing? Boom, boom, shakalaka, boom, boom. Huh. Huh. Okay, I'm not seeing anything rolling around there. And then we would be able to see, oh, that's a 3. That might have been the clock. This might be the data. That one's being held at above 1 volt, which is weird. And by the way, I've never seen something just take out something like I2C. Like it's just crazy. Doing ceramic caps on the spots for electrolytic caps can't be a reason. Over here, the reason that 1 microfarad capacitor is there, actually, let's double check. I'm pretty sure that's just because it's trying to kill a DC component in an output line. It's not. It's just sitting between 3 volts and ground. So like I could remove the ceramic. It's the same as this ceramic here. They're doing the same thing. Same thing over here with this one. This one's there just to take up a little bit of extra, like if something draws suddenly a lot. It could be something at startup maybe that this would be interfering with, but not really, because having a 1 microfarad ceramic there is going to be the same thing. So it's really not something that would trip us up necessarily. Do you have a second STM32? I don't know, because I built marbles for Julian and I think it uses the same microcontroller. I use ceramics to replace electrodes wherever I can. We used on our powered mult that I messed up so horribly, we used a couple tantalums, and just like any old tantalum, they immediately exploded. They were supposedly good for 35 volts. I don't know why they blew up immediately. Why would they blow up immediately? Ah, jeez, I'm so mad at everything today. One day I'm just going to come down here and just start randomly punching everything. Yeah, so I do not know what is wrong with this, and the further I play with it, the worse it gets. Our signal that's going into the DAC is good. See? It's good. That's good. No, it's not. This is good. It's, oh, we're, sorry. We are so fast that we need to slow down. Slow it down, slow it down. There we go. Look, beautiful sine waves. Beautiful. Beautiful. I know a guy who blows up caps instead of fireworks for New Year's. We tried to do an LED stream back in the day when I was trying to like do anything to get viewers and getting a little dangerous. We tried to have an LED stream where I blow up a bunch of LEDs because that's what my brother and I used to do. We used to take LEDs and we would hook them up to a 9-volt battery, and they would get real bright, and then they would not be bright at all, and then they would explode. And sometimes a little bit of smoke would come out before it explodes, but they changed the formulation of the epoxy for those LEDs, and so they no longer pop. It would have been nice if they could have allowed us to still have dangerous things in electronics, because a popping LED is very funny. It's the best sine wave. Hey, it's a good sine wave, all right? I don't want to oversell it. I'm annoyed. I'm annoyed because this thing is like flirting with working. It seems as though the micro refuses to communicate with the DAC for some reason, like it has beef. And I don't think it has to do with the filter settings. There's Clouds has, well, but it would still be communicating this signal into the micro itself, because all these functions are digital, right? It's in L and R, go directly into the micro. Or sorry, in L and R, go to the DAC. The DAC goes to the micro. Out L and R come from the DAC. The DAC goes into the micro. Position, size, pitch, density, texture, blend are all 10K pots that go into the micro. LEDs go into a shift register that goes into the micro. Freeze goes into the micro. Blend and save straight into the micro. All of these signals go to analog circuits that then go into the micro. We haven't been able to test if any of these work yet. Everybody communicates with the micro communicates with the DAC to make the outputs. So when it comes to communicating with the micro, these work just fine. They respond to me. Yeah, input should go to the DAC, and that's communicated with the micro. The filter is software. None of that should do anything. And we have traced our sine wave through the pot all the way to where it meets up with the DAC. So we know that we are sending it a sine wave. There should be data streaming to the micro, and there's not. So that seems to be where our link is broken, and whether that's the microcontroller not initiating contact with the DAC. I don't think it's the DAC, because we just replaced it. Luckily, I just found that I've got about 7 of these things, and I don't know why, because it's discontinued and it's like a $15 it's a $15 DAC. Anybody's building a Clouds, hit me up, man. I could use a couple bucks. That's beer money. I don't know why I got a whole thing from them. I think I stole them from an old job. But also, they were probably a lot cheaper back in the day. I don't know when I built Clouds. I think Clouds is like 3-4 years ago. So yeah, I'm a little discouraged today. I don't know what the heck's going on. We should probably have Clouds working just fine, assuming everything was right. It might be at this point, I may just need to reflash this. Sell them for profit on eBay. Hold on, let's see. Oh, that's Hello Fusion. Is it WM? I think it is. It's like waste management. That's for 50. $12? Are you kidding me? If there were, you know, every one of their dogs is trying to sell them, so there's no way that Oh Bother's WM8731 would be the one that gets accepted into whatever buyer's heart of hearts. But to charge $30, that's for 50. That's for 10. $30 for 10. Wow, I did not know that. Well, that's our little secret chat. Nobody can know about that. I have a hula for the DAC. I have a hookup. Yeah, you got a hookup for the WM8731, I guess. I've got like 5 of them. Well, let's see. Certainly you should not be putting these into new designs. Octo the bus. Where did that go? I lost them. I don't know where they are. I don't know. I lost them. I don't have them. I don't have them anymore. Yeah, I don't know what happened to them. They're gone. Oh well. Hold on, let me find these. I had to find some for a viewer. Oh man. Yeah, I guess there are equivalents of them now. Oh, those are op amps. Hold on, let's see. Where the hell did my WM8731s go? NFET. I think I buried them again when I put my stacks back together. Resonator, crystal, load cell. Not that one. Not that one. I've been sitting on a gold mine. WM8731 ADC DAC. Give me the... this thing. So when they don't spring, it's insulting. One, two, three, 4, 5, 6, 7. I have 7. Apparently I've got 7 of these. These bins have when tie written on them, but if you just look up SMD storage, you can find these. They snap together and they're pretty good. They just kind of boop display what's in them. Mega 328. Do I have STM32F103? That's not this one though. Which one is this one? Yeah, I can build 7 more devices that use the WM8731. Or I could source the equivalent. It's a 405. STM32F405. What I thought of, as you were flashing the STM, it should be okay and running. You know, like having your microcontroller do complicated control of LEDs says to me that the microcontroller is fine, right? There's an entire thread in Mod Wiggler. Oh, you missed what it was called. Didn't hit paste. This is 103. We need a 403. I got 8522. I got one of those. Shift register. I don't know where I got so many of these. I hope I didn't spend a fortune on them. I think I bought them before it was discontinued, though. You can order them as samples directly from STM. Really? Well, I got to give them all this information. They're going to hound me for the rest of time. Yeah, here's the Omnipod. I've wanted to make a microcontroller platform out of the main IC of the Omnipod insulin pump because there's more of these where that came from. I got a whole bin full of these pretty powerful microcontrollers that I've desoldered from my insulin pumps that have kept me alive for 2 days. Every single one of these has the weight of my shoulders upon them. And so if I could make some kind of a microcontroller platform that uses this NXP, oh, I guess it's NXP. I thought it was different, but yeah. Yes, 21270. You won't find any information under this part number because this is a custom QFN chip that is able, some of the pins I believe have FETs on them that are able to drive memory wire. They're able to drive memory wire in order to run the pump part of the insulin pump. Yeah, it can also teleport. Boink. That's just my tweezers having spring to them. Whoa. If anybody can figure out how to load software onto this, like we can make a little breakout board, like a little Arduino guy for this, and then we can have the bother micro platform. That would be my dream. Although I am about to eventually, I am going to be switching pumps, so this hardware will no longer be relevant. Yeah, reverse engineer and build a little Arduino style thing with a clock and a USB hookup. I would love that. That would be like phenomenal. I would love that so much. The problem is going through memory registers in order to figure out what the hell this thing is, because it's all internal to the company that makes Omnipods. It's all internal because this is special hardware. They've taken one of their normal microcontrollers, which if we could figure out what it is, they probably haven't done too much to it, and they probably stapled a couple FETs to it. In this die, I wonder if we x-rayed this, if we would see some kind of like here's the main micro and it looks just like all the other ones, and then we'd see 2 FETs sitting off to the side. Yeah, some licensed ARM core. Well, yeah, it's not generic hardware. It's if you're building 10 billion insulin pumps and you know they're all going to get disposed in 2 days, you go directly to the company and say, we want bespoke hardware because components cost more in a weird way. Yes, I got 7 of these things. I don't know what I'm going to do with it. Let's put all this stuff back, and I think I'm going to call it a day. Yeah, it's about closing. Well, I try to go for another hour, but if we run out of content, if he dies, he dies. If I run out of content, I run out of content. And sometimes I'll stop at 3 p.m., sometimes I'll stop later. It seems like we went down the same hole that we've been down before. We know where that hole leads, Neo. Neo, you know where that hole goes. You've been down that hole before. We ran into the mutable instruments conundrum, which is where something weird is going on digitally. All of the analog stuff, at least as far as we could tell, was doing just fine. I mean, honestly, I probably should inject a signal into it and check to see that our output runs are good. And maybe I can put use this as a control voltage and put that in here and then observe it all the way at the actual STM32 itself. Let me just show you that real quick, because that's an easy one. So if I put our sine wave into one of our CVs, I can then probe that cluster. And again, since we have this in Fusion 360, it's real easy for me to find what pins do what. It's real nice to have it just nice and labeled, but this is going from the MCP 6004. And actually, here, check this out. Look at that. So using that -10 reference to shift everything negative and then putting it through an inverting amplifier and using an MCP 6004 to do this, what we've done is we have limited our boundaries to 0 to 3.3 volts so that the MCP 6004 has no way at all of blowing up our microcontroller. As when we hit these MCPs, I love my MCP. There was a song a while ago, it was a tech house song, and it was about like fucking the MPC drum machine. Basically, the guy loved his MPC, he'd come home to it every night and tap on it. It was indulgent. It was a weird song, but every time I see MCP, I don't even know if that's the drum machine necessarily. I could be getting the acronym wrong, but every time I hear about it, I hear that guy like lusting over his MCP in the background. LBC, yeah, you know me. But anyway, so what that's doing is that's taking these different CV inputs, and it's, again, putting them right into the microcontroller. So whichever one we plugged into right now, yeah, the Akai MPC. I looked into getting one at one point, but they've always been expensive because people love them. They love those things. Make it purple. Make it purple. Why is that in there? Jeez. Make it purple. 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 Nope. Okay, we're up here. Make it purple. No, make it purple. Nope. Make it purple. Nope. Make it purple. You know what? Our I2C communication could be due to something going on here. What is going on? I am pumping a sine wave into trigger. Oh, well, that might be the problem. That might be a little bit of your problem there, is that you're putting that into a trigger signal. I don't think that's really gonna... Blend pot, texture pot, blend CV, V octave, 3 volts, density CV, poison pot, size, texture, size, N8, N7, LED, record, play, JTDI, JT clock. What is that? Oh, that's our programming interface. Like, I mean, these designs are not doing anything complicated, but they are amazing sounding. The newest version is nice, but the old ones are a pain to program and build sample banks. Well, listen, you're talking to somebody who went out of their way to jump up on eBay and get a 505. Because in promotional material for Kiss from the Rose on a Grave, you know, song that I've completely memorized, and I also have the harmonies memorized. I'm a normal person and my brain works normally. I'm sorry if you think anything else. But I went out of my way and I bought a 505. And I'm learning to use it. And I don't know, it's like menu diving. This is like the final boss of menu diving because it's Japanese and made in the late 90s. I know a lot of people using an MCP one just for outboard MIDI. Wow. That's fascinating. I'm hoping that I can get this thing to do some fill-in for what the modular synth is doing, but I haven't touched it in a week or two. We had to replace literally every button on it because they were just done. They were just too old. I think it probably sat outside for a while or something. Not too hard to mess with, but super fun. I hope I can make some stuff that sounds like music and I actually have some latent musical talent. There's probably a lot of work that I need to do there, but you know, I'm hoping that I'm not just terrible at that. I'm good at singing. I can sing. Obviously, using my voice professionally to do things like host a stream. I just jam on the presets. The presets are so wooden. They're like it's just Anyway, blend pot. Let's test all these and make sure they're working. This is the last thing we'll do today, just to make sure that we've got some functionality in this and that I can in fact blame the microcontroller. But if we find something else wrong with these, then maybe that's why it's not communicating properly. I don't know. It'll just send a program change. The new ones will host some virtual instruments that are good quality. Akai Juno. Wow. You know, the world of professional music making is not something that I've kept attuned with since the late 90s. I may be a lot older than you guys think that I am. What the hell pin is this? There's 1,000 pins here and they all do something. Oh my God. This would be... So 17 is the disrespect CV. This is density control voltage. And let's plug into density. Density control voltage is, God damn it, where is it? Dense, it's right here. That ain't looking good. That looks like something wrong. Well, actually, it's a control voltage, so I guess it is limited because we're going from 0 to 3, and we're currently, our channel 1 is at 0 to 6. So yeah, I guess that's appropriate. and then it cuts off in the negative because it's a control voltage. And it is opposite, so wait a minute, no, that means when it goes negative, this goes positive? Well, where's my density? Well, density knob is a different control. Why is that? Why is that influencing it? Wait a minute. What? What the? I guess that's the amount that the CV affects. But that means that our positives are cutting, but our negatives are permanent. I mean, I guess that's life, but that's crazy. Okay, that's a little weird. I'm 50. It all comes back around at some point. All right, well, that's encouraging because I'm pushing up daisies is what I'm doing. That's ground. This one is 3 volts. This one is V per oct. Okay, you know, we didn't need that. None of us needed that. We didn't need that. And then you just did that. V per oct is an input. Okay, so let's, it's under my hand. Shit. V per oct. There we are. So that gets us all the way to 3v3, and there's no scaling that. There's no tuning it. So V per oct works. These are all necessary things for me to test, chat. V per oct. Next is blend CV. So here's blend CV. Currently doing nothing. Freeloading bastard that it is. Blend CV. Where's my plug? Oh, it's all the way on the end. Ow, ow, ow. Okay, works. Blend CV, cool. This is probably what I should have done before even installing the microcontroller. I kind of lost my way. Which one were we on? There we go. So after blend CV, we have texture pot. So I'm going to plug this into texture, even though it's not related, and see if it shows up. Okay, good, it doesn't. So that one's isolated. But then if I go to the texture knob right here, there we go. Positive, 0, 3 volts, good. Probably just try to flash the microcontroller again, and if that doesn't work, replace it. Replace the microcontroller. I was like, replace clouds? Are you kidding me? I can't afford that. Okay, so this one is the blend pot. Where's blend? Blend is the only one that's been actually controlling something because blend is displayed on the LEDs. So I've been able to actually change that one. That one's been doing just fine. Blend pot, and then the next one's LED enable and S clock, and so we're not worried about that. Up here we have the position pot CV. Wait, what? Pot and CV. I guess that's what that means. So position, pot, and CV. So pause is here. That's going up only halfway, which I can't have. I don't have any control over that. And then position CV. Where's position? Oh, there it is. So there's that, and then our thing tells us how influential position is on our signal. Obviously, I'm putting like an audio wave into here, so just throw the whole thing into the bin. You have failed me once. This is all that I allow. Size CV. I'm not going to make a size joke, although I kind of just did. Doink. Okay. Texture. See, it's about the texture, not about size. Texture. That's this. Ah! We got hit with an ad break. I didn't even notice it. I can't see what I'm doing. We got jump scared by an ad break. Oh my god. Just send me the whole thing. Yeah, you take this curse. We were on texture. That's the third one. The third one's texture. We know texture, right? Texture does not work. Oh, that's the CV only. Texture CV. Yes, that works. 3v3 reference, ground. Hold on. Oh, God, I lost my place. The motion of the ocean, size, texture, 3v3, ground. Gotta move the mouse. I lost my place again. Pitch pot is somewhere up here. There are so many pins on this thing. Wait, why is that blinking now? Oh, wait, something just happened. What am I... Is it that that's doing it? Do we have like an output coming out of this? No. No. Huh, weird. All right, well, it looks like things are working just fine. I don't know, maybe I touched something that I shouldn't have. We got a minute and 5 seconds. Sorry about the ads, everybody. I just want discoverability so that I can get new viewers. We've been doing pretty good. I mean, the health of the stream has been decent. We don't get a lot of viewers anyway, but it's nice that, you know, we're looking a little healthy. Got no ads yet. Really? Ad break in progress. It ends in 40 seconds for some people. Okay, so really over here we've got the size pot. Oh, there's a reset. That's a reset pin. The pitch pot and the size pot, huh? Pitch pot here, and it's going to be one of these down this row. Let's see. So the capacitor is there, and so it's one of these. No. One of them's reset, so that would reset the whole thing. Oh, that's pitch pot. There we go. I just hit reset is what happened. So there's the pitch pot. As I move the pot up and down, our voltage level goes from 3 volts. Remember that this probe is on a smaller voltage scale than the other ones. And then this is, I believe, not blend. Which one is you? Size. Ah, and there's my signal. Ad break is over. Size. What's this one? There we go. All right, so all of our ins and outs, well, we don't know about the audio outs, but all of our ins are working just fine. All the ins are working fine. We should be seeing some kind of an output, and the DAC should be communicating input regardless. If we've got this at any volume, the DAC should be sending signals back to the micro who's requesting them. And I don't know exactly the push-pull there. Somebody's not doing their homework. What's up, Unethical Clown? God, it's like I'm insulting you every time. It's like I caught you stealing a rival's secrets, and I just have to remind you every time, petulantly. So we've been through hey, Velkinen, we've been through this part of the circuit many times. We've done it on multiple different... How did you get Unethical Clown as a nickname? I don't want to know. I'm gonna look at you and I'll be like, man, that fucking chat member, I can't believe what they did. Like, I don't want that. I don't want to do that. I do not know what is wrong with this thing, and it's frustrating me to no end. We are just at an impasse. My uncle called me that as early as I can remember. Have you ever been like, Unc, why? Why would you call me that? What is wrong with you? What did I ever do? No, it's man. Uncles like these, who needs fucking, I don't even know. Okay. What have we tested here? We've pretty much tested everything. We've looked at every single system of this, and we know that the CVs going into the chip are going into the chip, and they're all at the right level. I had a lot of trouble with pins that weren't connected in that pathway, so I wanted to test that out. Now that we know that it works, well, we know all of that. Why is that on and not... That LED is just on. Why is that? That should be turn offable. Why are you... What are you doing? Those are selectable. Those can be altered. Yes, okay. You guys can barely see that. I need something to like block that light back there. All right, just hit reset. Yeah, see, now it's off, and it does its little dance so that we know that there's a shift register over here that does these LEDs. So the shift register that does the LEDs is fine. Our power input is fine. Our 3-volt conversion is fine for an analog reference from the LM1117, as well as the bulk of the 3 volts from the big voltage converter. Our 12 volts is coming in just fine. Our signal input makes it all the way to the DAC and the gain on it is alterable with this knob. The 2 channels are a little bit discombobulated, and I might want to replace one of these resistors because it's off by just a little bit. What's that? The pins on the left side of the DAC could probably use some flux and a reflow. We literally removed the DAC and we put a new one in. These look rough because this is a white PCB and I hate the white solder mask on a PCB. These are flowed just fine. They work just fine. They're connected just fine. Something else is freaking weird. Have you considered smacking the circuit with a board or the nearest screwdriver out of frustration? You could do anything around here. I mean, anything is anything. You grill do, you get over here and do a little percussive. You could just take it and you could go, hey man, work, you stupid circuit, work. Come on, work. I need you to work. Start working. Talk to the DAC. It's right there. You know it's right there. You could just talk to it. Hurry up. Okay, try that. Now, against all odds, that did not work. Didn't do it. So this does its fancy little dance even after I hammer at it for like 2 minutes with a hammer. And what that's doing is that's allowing me to select 4 banks, and then the 4 banks I can select a blend. So then I touch blend and these flip over to either blue or green depending on what position the potentiometer is at. We've injected control voltages into all of these signals and checked them at the microcontroller, and we've got good inbounds lines that we can fully express. And that's something in the mutable instruments that I would suggest people do before installing the microcontroller, if you can handle installing the microcontroller in such a weird restricted area, is that I had all kinds of soldering issues with these initial steps to get us to the microcontroller, and that's what I had to spend a lot of my time correcting when I put together, you know, like marbles and so all the other mutable instruments. They had weird little soldering issues because everything looks like big electronics on these, but it's really, really small. We know that the microcontroller is communicating because it does its LED dance. It does basically everything that it should do. The data acquisition, the DAC, the WM8731, I have a bin full of these. Are they knockoffs? Are they good? Do they work? I don't know. I don't have any way of knowing that because they need a functional microcontroller in order to work alongside. I might consider moving the one that we removed over to a test board, a breakout board, and then sticking this onto a breadboard where I can get it to communicate with an Arduino. That might be something that I want to do. I don't think it's a hardware problem because we put a new one in and it is soldered in, and we know all this stuff is definitely working. You have to start the clock as a pull cord to start the resonator. If that worked, I'd have to change my faith. It's possible that hitting it would have lowered a pin to have it temporarily contact on a cold solder joint. This is the frustration with mutable instruments. They're wonderful modules. They do a lot of really good stuff. They're complicated, and if you build them in sort of the the same way that as the ones that ship out, all this stuff is like pretty much meant to be put into a soldering oven in order to get all these connections really nice. But you can hand solder these. I'm proof that you can. Just this is not proof that you can yet. I think maybe it's a reflash. I think maybe I need to reflash this thing. And I'll have to look into ways to do that. I don't want to drag you guys through the mud to figure that out. My name is Mud. So I can just put my electronics in the oven? Yes, actually you can, although I wouldn't do it in a food oven. You don't want to have the lead solder flux stuff in the same toaster oven as the one that you eat with. But if you go to Goodwill or any other subsequent reseller of kitsch junk, you can actually get an old toaster, clean it out, and you can reflow solder in that oven. Now you can't do the through-hole stuff, can't do the knobs, you can't do these funky con connectors. You can do the crystals, some of the other stuff. You got to make sure things have the right voltage rating. You don't want to do these LEDs that way. You know, you can do most of the stuff, and then you hand solder the rest. Yeah, I was actually a viewer sent in a bespoke reflow oven. This thing is a dust catcher, though. There's going to be so much dog hair underneath that if I turn it on, I think this is an emergency, this is like overloading the warp core to blow up my Starship shop. If like the cops come in, I'll turn this thing on and it'll let out like a dog smoke screen. I had to solder all of my mutables too. All of mine are hand built, and I built one for a friend. But they're very difficult. These are very difficult. Mainly just getting all these tiny little pins soldered. I appreciate doing them individually. I like to solder all the pins individually. But if you really have some equipment, or you do the reflow oven thing with a thermometer, solder paste down across all the pins and then dropping everybody in place. You can build that pretty easily. Just had a few capacitors, tombstone, yeah. You need to replace the tape on the T962 with Captain tape. There's a mod with a new controller to make it a lot better. The tape on the T962. What is the T962? You talking to somebody else? Use the hot plate, just tinned all the pads, tacked all the components on, and then reflowed it with a hot plate. It worked great. Yeah, that's the skillet is much better for what I do, because then I can get the camera on it. The reflow oven. Don't talk to me like you know what I've done with the reflow oven. I've already done that mod. A preheater? Yeah, a preheater would be good. I've seen ones that use a lamp. They use like a food lamp to do preheating. Yeah, we got Sid Heresy in the chat. If you guys are familiar, if you know, you know. People who know Sid Heresy like freak out. Oh my God, Sid Heresy is in the chat. It's like talking to someone on Mount Olympus. I'm not worthy of this communication. No, it's cool. Sid does a lot of this stuff. We do a lot of this stuff as a tourist. I am not super good with the music stuff. I'm good with this, like the soldering stuff, but we've decided to do like just some fun stuff, just messing around with some of these, and I've been having fun. Took a break from inhaling fumes to watch an awesome stream. I appreciate it. Yeah, well, today wasn't an awesome stream. Today we fell into the mutable hole, which we've done before. The mutable hole is this module that I can't seem to troubleshoot properly. We did confirm today that everything hardware on this board works. So I've pretty much narrowed it down. I think it's this guy right here, and I think it might just be due for a reflash. I may have found some piece of cursed software and thrown it in here and gone, sure, yeah, that's totally right, but it's meant for like Dave's crimes and I don't know, Lamentations module, which is a slight alteration of the clouds that doesn't use the WM8731 because it's got a $15 price tag. I'm not sure. It's the journey, not the destination. That is true. I found No Bother through Sid Heresy. Hey, cool. I mean, we got some other stuff that we want to do on this stream other than this stuff. The synthesizer stuff has been very interesting because there's a lot of characters. You know, far be it for me to call Sid Heresy a character, but there's a lot of characters and there was a lot of lore. I bought this one power distribution rail, and my buddy Julian, who's Zelikovich Music, if you guys want to check him out, he's been producing music my whole life, and he makes some great stuff. Zelikovich. But Julian comes in and he looks at this power distribution rail that I've installed in the case that he gave me, and he said, never buy from that guy again. And I go, huh? Why would I never buy from that guy again? He was like, his like whole expression, haha, jokey, haha, never buy from that person again. Like, oh, okay. Apparently they went off the dipshit deep end and did a whole bunch of racist MAGA tirades on their whole website and everything. But when you go to Amazon and you look up the simple synthesizer stuff, oh, this looks neat. Yeah, that's who it was. I'm not going to say the name on my stream. apparently, the whoo, ba, 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 ding dong. Yeah, he's hated. I already bought it and I couldn't return it. So those are the rails that I've got. Well-deserved hatred. See, this is what I'm talking about. But then Emily Gillette of Mutable Instruments made these world-class, amazing, ultimate designed modules that are just like, they're just perfect. And apparently the community, was it? Or she just went crazy and went, fuck y'all, I'm out. Cloud of smoke. But left all the design files for people to work with, which is just, wow. If you're going to go out, at least help everybody else who isn't a dipshit and pissed you off into leaving. Because now those are like the basis of just got burned out. That's all of these creators have lore behind them. They've got lore. It's crazy. I've been using the mutable designs because one, they're in Fusion 360 and I can just cut and paste. Although I haven't cut and paste them, I did take her thonk module. Her thonk module has a bunch of different sizes for how compact you want that ground pin to come in at, which is pretty neat. And then I found a GrabCAD 3D model for it that was really nice. So I know I would absolutely watch a video where somebody interviews her. But I listen, I feel like I'm still a tourist in this whole modular synthesizer thing. I feel like I need to go to a show and maybe I need to make like a module that people actually want to buy, and then maybe I can feel less of a tourist. Then maybe I can talk with authority. Maybe I could go try to get an interview, but I ain't that guy. I'm not that guy. Why is there a camera in my face? I was showing Sid. We want to get to other projects here, like this giant hunk of money and time that has real car parts in a simulator setup. This is a digital BMW sports seat. It's not very sporty. It's kind of like hard leather, but I can sit in this and approximate feeling like I'm in my normal car, except because that seat speaks CAN bus, I can hook that up to the chat interaction tools. And so chat can try to fold my clothes while I'm still wearing them, while I try to drive somewhere in a game. I'm looking forward to that because that's the natural conclusion to the steering wheel that uses a giant 2 horsepower servo motor and a real steering wheel to play my summer car. I won the rally, so we're gonna bring that to its next iteration. Yeah, it'll be a lot of fun. I mean, mainly, if I give chat control, they're just gonna control it. But I think I'm gonna make the penultimate expensive thing to turn on the seat heater, because I believe there are seat heaters in there and they're not behind a paywall. But I'm gonna put them behind a paywall. The great BMW seat heater paywall, because the seat heater needs to stay on surreptitiously, so that while I'm driving, I go, hey, did I piss myself? What's going on? Oh, the seat heater's, and then I'll deactivate it, and then chat will inevitably activate it again immediately. So it's gonna have to be expensive, I'm warning you guys. Moving the seat around can be cheap for little moves, but the pain wall, yeah. I put it behind a pain wall. Isn't that what those cave divers do? Like as soon as like a tiny little 2 rocks separate by this much, all the cave divers descend on it and try to squeeze themselves through. That's kind of, yeah. Okay, I don't know what else I can do with this other than flash it, and that's going to be kind of boring. We know that everything works. That's actually a pretty good one, is that we know everything on this works except for communication between these two. They've got beef. I don't know why. So I want to get to the bottom of that eventually. I have this whole pile of filters sitting next to me. For those that know DIY modular, I want to bring you guys on a little journey here. I've got 3 Toms MS-22. It's fully built. All I need to do is a little bit of soldering to kind of put some of the hardware together, and then I'm getting 100 Thonky Kongs tonight, like today even. Thonk is the way to go. If you're in America, by the way, ordering from Thonk, the Royal Mail can reimburse the tariffs. So it takes a couple days for Royal Mail to get here, but Thonk, through Royal Mail, you're not going to be paying out the ass in tariffs. I had to pay $40 in tariffs for all the parts that I got for these things. NLC. Of course, half of the things that I buy are NLC. nonlinear circuits. This is the digital filter simulator. This uses a flip-flop to take audio in and turn it into 4-bit, I guess, and flip-flop it over to the output. I don't know if this works, and we got to figure out how. We're going to work on this and others tomorrow. The NLC low-pass gate, it needs a Vactrol. We'll make our own Vactrol for this eventually. Flashing the chips seems to be the biggest hurdle for people. I have many posts in my Discord for people asking how to flash them. I've got multiple different ways of doing it. One of them is with Platform IO. Everybody seems to love Platform IO. I don't personally use it. I like the Arduino IDE because it's as simple as a cudgel. I like my tools to be MS Paint. I've gotten an STM32 core for the Arduino. I don't know. I think you can flash a hex with that, maybe. Yeah, the actual brand name is King Poo for the Thonky Cons. And don't get the bad one. This is something that I always tell people. But yeah, okay, the modules. We've got a Sirius filter. That was the one Julian was using the other day, and it needs a little tuning for the CV. I have, what is this one again? Oh, the Echo. This is Delay No More from Nonlinear. This one has all the right parts. It should be good to go once we put connectors on it. 570 galore. I gotta find a schematic for this thing because hot damn, that is a lot of troubleshooting to do. Somebody was an evil little module maker and they decided to put a whole lot of functionality and not a whole lot of space. And I decided that I would love to go through all of the parts that I own, finding the individual value of every single leap of this analog atrocity. There are so many tiny components that went into this thing. This is an 0603 masterclass. You love Delay No More? Oh, that's good news. I actually chose something that was okay. This is me going through Modular Addict and just looking at the circuit boards and deciding something sounds interesting. I'm going to go with SynthCube next because I heard that Modular Addict stock is like kind of old stuff. How many layers? It's 2 layers. It's actually kind of a brilliant design, but it uses a bunch of these 570 compandors. Da-da-da-dun. The compandor. So I think what it is each one of these is an example circuit of what to do with the compandor, and then there's some kind of a gate going on all the way up here with the LM39 something or other. My advice with the Thonky Cons, by the way, is do not buy the bad ones. And the bad ones are these guys. Oh, we're still in super up close. We're going to be super up close. We're going to get a little bit intimate here, chat. This is one of the bad ones. How can you tell? It's got big round pins on the bottom for looping wire through. And that's a dumb way to do it. There is no metal collar. That goes to plastic. So the mechanical engineers among you would know if you tighten down a bolt on this, it is going to put all the force into this plastic body. And because the ground pin is held on as a plate with a little like rivet curl, it will extrude through your ground plate, disconnecting it, disconnecting your front panel, making your mama cry. It's just the worst. These are the worst. So don't use these. And if you have these and you have to use them, then you need to use, hold on, I got one in here somewhere. Don't be fooled. Do not buy a $40 tool to tighten up the bolts on these audio connectors. I don't have one in immediate grabby distance. This is the one you should use. It is a hex. It's, I think 10 millimeter. It's a 10 mil, so ask your mechanic friend if you can borrow their 10 mil to get that on. These you can tighten with a wrench because you're not tightening them against that other connector. You're tightening them against... No. Close your eyes. Oh, it's 2 of them. It's a plague. Hold on. I got a good one in here. There it is. You tighten this one with a wrench. A wrench will hold this down because you're tightening it against metal, right? That's the good one. I am in Europe. I only have metric. I am in Europe. We do not have music. That's what I thought I was reading at first. Yeah, these are the bad ones. The nut that you use on those is rounded, and they sell these dirty synthesizer maker websites. They sell, here's one. They sell a wrench for tightening this. It's a little handheld thing. You don't use that though, because a wrench will break the connector. Do not use the screwdriver. Do not use the screwdriver on this. This is hand tighten only. And then they'll loosen up on you. Honestly, if you want the engineer's perspective on this, get a little bit of Teflon on it, like a little bit, the white Teflon that they send you with stuff that you're not supposed to use on anything. Use a little bit of that on this, and it'll tighten this up so that it doesn't loosen. And tighten that up to finger tight. You can maybe, you know, get your nail on that little thing right there and give it just a little tweak beyond, but don't go any further than that. Because if you tighten this with a wrench, it'll extrude your connector, and then you have to go to your soldering buddy again after they've already repaired your power supply because you blew it up, because you keep plugging in your modules backwards for some reason, and you have to then say, hey, can you desolder this connector and put a real Thonky Con in there? And then I have that exact scenario to talk to you guys about. Just use Loctite. I mean, practically, yeah. If your synthesizer is going to be like at the club and it's going to be, you know, vibrating a lot, then maybe that's a good idea. Yeah, this is the 570 Galore. It's a little dense, and the silk screen on it was awful, absolutely terrible. And then the numbering scheme for all the components was confusing and hard to follow. What the hell component am I putting where? There's just a marking out in space. Luckily, one of the viewers here actually found, wow, what is going on with that capacitor? They actually found like a PDF with a bunch of material of the 570 Galore. I'm hoping to find a schematic. I think there's one out there. I saw a link to it. And so if I find a schematic, I can troubleshoot it a little bit. There's still some wrong stuff. Yeah, the purple's nice, but the silk screen is like falling off. So I can't tell heads or tails of what's going on. Yeah, it did. So when you move down to 0603 and 0402, those are the 0805 is like comfortable soldering. 1206 is for large current loads and stuff like that. At least in my book, this is how I justify all the sizes of surface mount. These are mil dimensions of the square chip, 0805, right? 0805 is pretty good. 0603 is doable, but things start to get a little challenging. And 0402 is impossible. Everything looks like it's larger because you zoom in on your microscope and you're taking a look at this big thing and you're trying to adjust where your tweezers are and stuff, and any of your tiny little muscle movements are magnified. And so you feel like you're actually really bad at soldering. Yeah, 0603 requires a little steadiness. 0402 is I have been backed into a corner and I have no choice but to service this thing. So yeah, that's my needle tip only goes so small, and then you have to get creative with anything smaller. It's insane. But anyway, you know, you need like a Da Vinci robot for anything smaller than that, which I would love to build something like that for stream. Just make it look like my hands are actually moving stuff, but they're two like super high power precision industrial robots that are moving the things. Lasers. Yeah, maybe lasers. Actually, they do they do laser soldering. That's how they do some production stuff. You got a laser, just goes to all the stuff that you solder, right? We got a big storm rolling in here in the Northeast, and so actually, is that? No, it's tomorrow. Tomorrow it's supposed to be kind of poopy rainy. We already got our big storm. Everything blew up. I'm actually just going to end so that I can say hi to my dog, walk my dog. Yeah, we're going to come back tomorrow. My brain's broken from all the troubleshooting today. We don't know why Clouds isn't working, and if I can figure it out, we could try to throw new software on there. Today, I was supposed to be looking at my oscilloscope because apparently it's a beast. We can put a whole bunch of windows up on the thing and have like Fourier transforms and stuff like that, and actually characterize some of the filters that I'm desperately trying to finish building. My Thonky Cons are in the mailbox, so I'm gonna go get those. Tomorrow, we'll add connectors to filters, and maybe we can run them through some simpler tests. They're gonna look cool. It's gonna be a lot of data floating around, a lot of numbers flittling about, but basically what we're looking for is a curve, and then we'll tune to that curve, right? That should be nice and easy. That should be a little easier than what we were doing. Yeah, man, I appreciate you guys being here, and especially people who have never seen the stream before, found me through another streamer. You know, if you're watching me for free, please, you know, make it right and go out and buy the tapes. Wait, no, that's not what this isn't. No, this isn't like that. Wait, never mind. Never mind. That was irrelevant. That was somebody else's send off. What are we doing here? Why are we here? Why are we on this planet? Let's see who's on Twitch right now. If there's anybody that I can throw you guys at. I don't think we'll do a raid. I just want to check quickly. I mean, Midnight Sumo's on. I might be watching that. Davies is doing last. I don't know what last drop is. If there's somebody playing approximately up, I would love to show you guys that. Garrick Durock is, if you speak the language, Garrick Durock is doing some really good programming. They're always up to something cool. Let's see. Uo is not around yet. I never get to raid Uo because he starts like an hour after I finish. I may stream myself in an hour, food first. If you guys are looking to check out Spiral Grooves, definitely check out Sid Heresy if you guys get a chance, because Sid Heresy is better at this stuff than I am. I think. I haven't been able to sit down and watch a full stream, but Sid is definitely one of the special people on Twitch that you guys should check out. So I'm out of here. I've been signing off for like 20 minutes. It just has to